Baik. Okay, new project. New project before. So what you do? You create inputs, that is start M1, stop M1, start M2, stop M2, start M3, stop M3. Then output motor 1, motor 2, motor 3. No programming, just the typing. This is the program. No, just delete. You just delete the network. No, you can delete the whole network.
Delete the whole.
Yeah, you click here. show all that. Okay, this one delete. What is this? No, the first one delete. Okay, this one start one. We change the. Okay, stop one, start two, stop two. Okay, then this one Moto 2, Moto 3. Oh, save. Now what you do, go to add new block. Okay, so we add a function block. Function block. No, function block. Yes. Okay. Name it motor control. Motor control FB. FB.
Yesterday was function, right?
FC, yeah. Yesterday we use FC as a subroutine. Subroutine, because FC can be code block in subroutine. Okay. So now we want to use the function block as a code block, and later FC also as a code block. So both also can use as a code block.
So which one is better?
Later we see.
At least we can select which one is better.
Yeah, later once we do, we see the difference. What is the advantage of? Then we know that when to use code block, when to use FC. I mean FB and FC. Okay. Okay. Ladder, I'll choose ladder. Okay. Okay. Now, function block, right? Okay. So, like FC also, you can do a program here. Like a subroutine also you can do lah. But normally we don't do like subroutine. Subroutine you know, right? Means you do program, whatever program you do in the OB, you do the same program in FB or FC. That one we call subroutine. Okay. Now we want to do a code block. Okay, code block means you need to do the coding here. Okay. Coding is normal ladder only. Normal ladder logic. But the tagging we use internal tag. Okay, what is internal tag? Okay, you click here. Okay, so we can declare input, output, in out, static, temporary, constant. So all these we can declare and use here. Okay, we use in our program lah to create to build a program. Okay, so later we do one by one. See, yeah. Okay, now in the input you add start stop. In the input add start stop, in the output add motor. Just start stop, no start one, no start two. Just start stop and motor.
Output is motor.
No, start
And stop.
Start and stop. No. The next one is a stop.
And motor, like motor 1, motor 2.
Motor is output, only one enough. Motor enough.
So no need to mention like 1, 2.
No.
Okay. Output is motor.
Start, add a stop. Second one is a stop.
Okay.
Okay, and output is motor. Output below. Yes. Okay. Save. Okay, so later we see that in out, static, temporary, which one you want to use. Make it open. Make it close. Okay, now you do the program here. Put anomaly open. Okay, double click, click here. Can you see you have this start stops and this start stop motors? Right. Okay. So like I said that day, the first day, the percentage mean is what? Global. Means all the blocks can use. Okay. But this one the start stop motor that I created here, right? I only can use here. Inside this block. Later I have another function block, that the function block also can use. Okay, if I create another function block, the other function block also cannot use this. Means whatever I create here, I only allowed to use in this function block only. Okay? Now you do the normal program, start stop motor with the latch using this. Okay, save. We do simple program. Alright. So here don't have the IO, right? Okay, here we use okay. Now we go to main. So we need to, you see, code block means it's like similar to timer. Means you need to call somewhere and give the data. Then only it can work. Same way also our function block. So we call here and put here. Drag and put it here. Okay. So you see, same like the timer, right? Whenever I add, it asks you to put a name. Okay, you put motor control 1 FB. Motor control 1. Okay. FB. Yeah. Alright. So it become like this. Right. So inside here can be any program. Okay? But how it form this one? Okay, whatever you key in at the input will be on the left hand side. Whatever you key in on as the output will be on the right hand side. Okay? If in out also will be left hand side. It's like in out lah. Okay? Then static, temporary, constant. These three data will be inside the block. Okay? Okay. So now you key in the start one, stop one, motor one. The start one, you created your logic in the PLC tag. Yes.
Fail is motor is the motor one.
Yes. Okay, save. Okay, you add another FB beside here. Okay, this one motor FB2 or motor control 2 FB.
New block lah.
Yes, add new. Don't copy paste, add new. This one can close. We're not using, you can close. Yes, okay. Now you add start, stop, start 2, stop 2, motor 2. Okay, so this is called code block. Means you create one logic, then multiple time you can use. Okay, you download it as can. Okay, Moses. You just save download. No, cancel first. This one is a stop. Right. Where is it? Stop. PB1 here. Okay. Then this one is a motor 1. Yes. side here.
Yeah.
Yes. We drag and put the function block. Function block. Yes. Okay. So this one motor control 2. Motor control 2 FB. But the name can be any nearby, it's up to you. Okay. But make sure you can understand. FB. Okay. Then here start to stop PB2 motor.
That means we just pull the motor, I mean the block in line, will automatically create a new file.
If you create the DB.
DB, yeah, DB file.
Yes, of course. Function block, every time you call, you create the DB. Why? Because whatever data of the function block will be saved in the DB. Later we see how the DB function at first. Because this program very simple. Okay.
One question. Yesterday we use the pro interface to doing the function. Doing the function. We did not like doing the start stop.
Yeah, no.
No. So it's totally different.
No. Yesterday,
Yeah.
okay, we use the FC, right?
Yes.
We use the FC as a subroutine.
Yes.
Subroutine, right? Subroutine no need to do that.
But
If you want to do as a code block, then you have to drag and do. Yeah, the FC also we do one.
But this like the block when the first motor on, the second motor.
No. You test for that, I say. You go to the FB process, you go to the FB. You latch the motor. Have you test or not? You just test and see what happens. Just test and observe, you see what happens.
Latch the motor.
Must latch, huh?
Latch.
Yesterday computer was able to fast. Now it's like very slow.
Oh, a minute. You search first. you go to accessible device, you download. Wait. Okay. Go to online. Download the device, right?
It's just like the normal start and stop.
Almost has to talk on me. But what you see there?
The green light always on.
In one life you can do a lot and continue with it.
No. What is here?
Easier, make it easier, simple.
No, set about.
Make it simple, one line, that's it, finish. No need to create a lot of the block.
Yes, that is the concept. The
Ah.
concept is very simple.
Very
You have a repeated system, repeated process, which is similar, but the I/O is different. Correct? Because for motor 1, the I/O is different. Motor 2 I/O different. So
yes.
I create one logic that I can use call it multiple times. Then each one I can give it name motor 1, motor 2, then it can run it.
Yeah.
So there's no save bytes, no. It's just make us easy to do the program.
That means like
Means I create my own coding. That's all.
this one is just like a very simple start and stop only. Like any control can be, create.
That's why I say you need to understand. Any repeated process, so it can be any process. Here I just show you start stop motor because one, we don't have much time to do bigger programs. Okay, then I make you understand this. So can be any. Let's say the tank program. Let's say I have 4 tanks with a similar process, but the timing all different. Right? I can do one program in the function block, then I can call 4 times one.
That means I have 5 tank. I don't need to create a lot of the network. 1, 2, 3, 4, 5. I just create the file. The FB
In one function
in
block.
one function block. Then I just copy, put for the 4 column there. Finish.
Not necessarily one network. I can put below also can.
Below also can, but not so complicated to write one.
Not like that. No need to write the same program multiple times.
Multiple times.
Yes.
Maybe we just like one time, we just copy, copy.
Yes.
That's it. Then only the supply, the start, stop, only different on the input.
Yes. All the input output will be must be different.
Yeah.
Input can be same, but output must be different, and the process all the time must be similar
Okay.
in terms of the functions.
Okay.
It can be different in terms of the size, the timing value, all that can be different.
Okay.
But in terms of the function means when I start, valve A on. Once I reach low level, timer run. All that functions, that flow must be same. If there's one different, then I cannot do it.
Okay, one thing like I just want to check related this kind of function block, right? There's a start, stop motor. If I don't use the start, I don't use the stop, I only start and motor. Like for example, like timer or something.
Can. That's why I say in the block you can create any program. In the block you can create hundred of network of program also can. No problem.
We just want to simplify
Yes.
the
Make
network.
our life easier.
So, so yesterday we did the FC with the on coding of the ERAC, with the encoding like the map function, other function.
Okay.
This one data block we're doing our own.
No data block, function block.
Function block we're doing our own coding, so that we
Yes.
Can we set this one into the
FC.
FC?
Can do. I haven't teach you yet. Wait,
Okay.
don't worry.
Oh, okay.
Okay, I can. Don't worry. Okay. I want you to. This one understand or not? Understand? Okay. Now.
One question.
Yes.
Since we are in the same line, right? We are in the same level. Well, let's say without open this one, but I still can open. Without open the first one, I still can open the second.
Can right?
Why? Because we need.
Why?
Because the function, the bottom here not start yet.
Why I can open this?
Yes, even I didn't start.
Why?
There is no any normally open. Block the line.
Because can you see enable? En means enable. ENO means enable out. Right? So the signal is I enable the block to run. It's a green, right? So there's no interlock lah, right?
EN is enable.
Yes. I don't have any interlock here, right?
Yeah.
So it can run. Unless I put some interlock, then only can run.
Is
But
it like
normally we don't do that lah.
Is it like the
Enabling the block to run.
we can run, but have to depend on the block. We want to run or not.
Yes. Okay, okay.
Okay.
Now the same thing we can do in FC also. Okay? Okay. You add new block. Add new block. Okay, FC. You name it as a motor control FC. And you do the same thing. Start stop motor, you create a simple program.
This one the FC using our input output.
Use the same. Open, put in the input output, start stop, motor. The similar program. Same program.
Why I cannot do like
You want to do the latch? Why?
why? The yellow become
It's not very can do, but what error? Not error, warning, right?
yeah.
Never. It shows what? The tag is declared as output. So it would allow you to read access is not recommended. Means I on and I want to read the value, right? It's not recommended. Okay? Means in FC, if I want to do latching like this, I must use the mode to in a in out. Can use at the output. Okay, won't latch. Never mind, we test this, then we can understand.
So that they have like it
I leave you leave it because it's not error, it's a warning only.
yeah. Not right.
Yellow means warning.
Red is not right.
Yes. Red is error. This one will just give you not recommended. Once done, just go to main, then add the FC and the level 2. FC, yeah. So you see, when you call FC, didn't ask you for the DB. Right? When you take and put the FC, it didn't pop up for a data block, DB. Correct? Because FB no need the DB. Sorry, FC no need DB. So function block, when I add, got DB. Right? You add a function block here, later we will do it. You see, got DB. Right. Okay, asking for DB. FC don't have DB. That is the first difference. Okay. Okay, now you see here. Function block, right? Okay, let's say this one DB lah. Function block. You see, if I didn't key in anything here, it's still okay. It's not error. Okay. But for FC, you see here, if I didn't key in anything here, it cannot run. I cannot even download. Okay? Why? Because like FC for function block must have a DB, right? And DB lah, adding DB lah, okay? How many times we call? It will be DB1, DB2, DB3, DB4. Similar like your timer counter, okay? Okay. You see, this one, let's say in, out lah, right? In, out. You see, this one, if I didn't key in anything also, no problem. Okay? But here, it's a question mark, like I must key in values. I must key in any address there. Then only it complete. Okay? So let's say I put input 1, input 2, output 1. Okay? Here, let's say I only have input 1. This one don't have. I can leave it, no problem. Output 2. Example. Okay, why? Because this data will be saved in your DB. Okay, so DB is like the backup for the function block. If I didn't key in here, it can save here. Okay, so for example, I do one. Let's say function block 1. I have a start, stop, the motor chip. Okay. DB2, DB1. Now let's say that I do one program. Inside here, I start, stop, motor, change motor. Okay. Inside there's a program, so I don't care what program inside. Okay, inside here can be any logic, but the arrangement here, whatever you declare as the input on the left hand side, whatever you declare as the output on the right hand side. So now, for example, for the motor 1, I have a start 1, stop 1, motor 3, okay, motor 1 input lah. Okay. Then this one is the motor 1. So for this start 2, stop 2. Let's say this one don't have motor trip function. No motor trip contactor or something. Can work. Okay, even though I didn't key anything here, it still can work. Why? Because the data will be saved inside your DB. Okay? That's how it works. But here, let's say for this, I have something in 1, 2, 3 example. So if I didn't key in here, it won't complete. Okay? So means both also can do as a code block. The FC also can do code block, right? Because the data for simple motor like this, start stop motor, for this, what data I want to save in the DB? Nothing, right? I'm not going to save anything in the DB because all the data here. So this program, FC can do like this one. Right? Okay? FC also can be called multiple times. Code block means can call multiple times. Very simple. Okay? Code block can call multiple times. Now, what is the difference between FC and FB is the data block. Okay, the DB at the back. Yes?
One question. Let's say FC don't need to set the data. FB set the data. So what is the losing?
Yeah, I won't go yet. Okay, I will tell you what is that. Okay, it's the DB, right?
Yes.
DB later I will show you why DB. Okay. The first thing I want to understand is this the format. How it works. Okay? FC also can call multiple times. The function block also can call multiple times. Both are same thing. Okay? It's depend on your program. Let's say I have 5 motor. 5 motor also start, stop, with the timer, everything. Okay? So I can do in FC also. No need function block. Because FC also can do code block, right? Okay? Unless, okay, 5 motor, some motor don't have stop button. Some motor is automatic stop. Okay? In that case, I use the function block. Because for some motor, I don't need to key in the stop button.
Can we clear like this between FB and FC? FC, we need to put all the input.
Yeah, of course.
To fill up all the FC.
Yes.
All the information needed for FC.
Yes.
Then for FB, some you need, some you don't need to key also.
Yes. If you don't have, also no problem. For first motor, you have everything. For second motor, one data is not there, so no problem. Because it can be keyed in the DB. DB will keep the value.
Let's say this program we're doing, we only key in the start, but we did not key in the stop.
Which one?
The FB.
FB. Yes. Still, you can download, but of course the program won't work lah. Because why? You don't have any timer, right? Unless we do timer. Okay, later we do timer. Okay? Okay. This one you delete. Delete. Okay, now you add a start M3, stop M3, motor 3, division. Action. Then the FV also some other functions also lah. We do first. Then you download and test lah. But it won't work.
Won't work.
The motor, just now the motor when you latch right got some warning right?
Yeah.
So it won't latch. Oh. It won't latch. Cannot latch, right? Cannot latch, right? Correct.
Latch me.
Cannot hold, right, the motor.
Okay. Oh.
No, the up one you're using push button.
Yeah.
Okay, the down one you're using selector. So you on lah, but if you off back. Cannot hold, right?
Yep.
Can hold lah, understand lah? Okay, I don't want you to confuse. Okay. Why? Because of in the FC, if you declare as the output, you cannot do the holding, the latching. So what we do? Okay, go offline. Go to the FC. You cut and add here. Okay. So if you want to do latching in FC, must use as the in out. Wait.
Okay.
Cancel. So wait, I do changes in the FC. Correct. Means it doesn't matter I change logic, right? I do changes here, right? So what I do, you go to main, need to update. It's not automatic. You click download, automatic update. Sometimes you need to manually update. Okay. So can you see? Come to left hand side one. Can you see the arrow in out? Okay. Now you download everything. Monitor. Okay.
Why we need to put an column in out?
That's how it goes. The FC, in the FC, if you put as an output, only you can use in the output. Means it cannot use as a normally open or normally closed function.
That means they cannot only in one line.
Not one line. Can be used as an output only.
Or
Can be used as a coil only.
cannot latch
Cannot be used as a normally open to do the timer. So cannot.
Okay.
So must use in outlet. Okay. So that is one drawback lah on this. Okay. Now, is this one okay? Moses, okay? No, because it's the I 0.4 and 5, the last two buttons. Off? No, off the switch. Okay, and hold, right? Just now cannot hold, lah.
That means the function, all the output, if you want to latch, have to put at the in out. Some like you need to
Latch
latch,
to latch, some space you need to latch something.
you just need a signal or something like this.
Yes.
You don't need to latch,
Yes.
then you don't need to put output, stick back to the output.
Yes. Okay, now we want to add a timer and see how it works. Okay, go to FB1. FB1. Okay. You add the motor here. Add a yes. Add a branch. Normally open. Why so slow? And during lunchtime, I think it's quite. Wait, you add timer, but wait for me. You add, normally open. Okay. Motor. Okay. Then add a timer. TON. Okay, drag and put here. Wait, don't put here first. Okay, the timer don't click anything. The timer pop up, right?
Oh, yes.
You click the reload it.
Wait.
No. Oh, okay. Alright. So this timer now. So you have 3 ways to call the DB. Okay, we know timer it will call its own DB, like our function block. Our function block and timer same concept. Okay. Okay, now so when I use a timer inside a function block, okay, can you see single instance? It means like normal line will create its own DB. Okay? Okay. Multi-instance means it won't create the DB. Okay? It will share with your function block DB. Okay, it means now I have 2 function block, right? 2 function block DB, right? So if I click this one, it will share, so it won't create its own data block. It will share with these 2 DB.
Multi lah.
Multi.
Okay.
Okay? So means you can save some DB. Data block lah. DB got 65,000 lah, but for timer no need additional DB one. Okay, you can share that same DB. Parameter instance word means I use the share, but later I have an option to create additional DB. Okay? I will show you. First you choose this, later we can delete. Name no problem. Just click single instance, click OK. Okay. Can you see? Created 1 DB, right? Then create 1 system block DB. You click here under system blocks. Program resources. Can you see 1 DB, right? Okay. But I don't need the DB one. Correct? Why I want to waste DB? I can use the internal DB. Okay? We do one more again. You delete this one. No, you choose delete. Okay, and this DB also can delete. No need. Okay, you add again the timer to here. Okay. Now I choose the multi-instance. Multi-instance parameter is it's the same thing, but parameter instance is later if you want to add a DB you can add also additional DB. Okay, use multi-instance. You put a name like timer 1. Okay, okay. So can you see no DB, right? So what happened? This data no DB. So this data will be saved in. You click here. will be saved under static. Okay? Okay, it automatically saved in static. So your whatever your timer, your counter, all the DB type function block type all will be saved as the static. Okay? Static means it's like internal only, inside the block only. Okay? Now you go down. You add a 10 second first. Put 10 first. Okay, enter. Now normally what we create one memory and cut off, right? Okay. Go down here. So in out we know, right? Okay, now we see what is static, temporary, constant. Constant later we do lah. Okay. Temporary means is within the block only lah. Okay, so no need outside. Outside the block like this won't request. Okay. So, but temporary means within the block and within the line only I can use. Okay. Within the block and within the line only I can use. Okay. Later we do one example. Okay. You click here. You add one output. Okay, you give it a name lah, motor off. Enter. Enter. Right click, define. You put not global memory. I don't want global memory. Local static. Click define. Okay, use sometimes you erase because no hashtag in front. Right, okay. Just erase, just type in motor off. Okay. Choose the motor off. Okay. Okay, why I use static? Static means because this is another line, right? Right. From here I want to use another line, right? So I must use static. Static is like that inside the block only. It will process inside the block only. Like a memory lah.
Inside the FD.
Yes, like a memory lah. Right. You see, I we did external input. Q we did external output. Like this lah, for example, let's say this one I do in normal program. What do I do? This is input, this is input, this is output, right? This one we use memory, right? Why memory? Memory is inside the PLC, right? The same concept inside the function block. Okay? But static means can use in different lines. Means I on here, then I can use here.
But inside the block.
Yeah, of course inside the block. Okay? Temporary also is inside the block, but within the line. Okay? It's within the line only. Okay, later we do one. Wait. I will do one example, then we can use all so you can understand better. So later you can use reference also. Okay, you do one for motor off. Here normally close. Normally close motor off. Okay. Go to main OB1.
This one, temps is like in the line only.
Within the line only.
They made at the block, the line only.
Yes. You can transfer in within the line only. Okay. Wait go up. Okay, can you see red color, right? You know why? Because inside there we add the timer. Timer, right? Timer, and ask the timer to share the DB. That's why. Okay, right click here. Update block call. Update block call. so it can work. So can you see it didn't show here. The timer, the motor off all didn't show here. Correct or not? Okay? Because it's inside the block only.
So they make all the block will change and add in the timer. If single, only single, that one.
Right.
That means this one we click, right? For the timer, right?
No, yes. The single DB.
Yeah.
Single DB means it will create another DB, that's all.
You mean only for that DB? Or that
For the timer,
Yeah.
it will create another DB,
Mm.
that's all. If I use multi-instance means it won't create a DB. It will share the data with this data block.
You mean inside the data block already have the
DB, yes, the timer. You open the data block and see.
That means single, create a new DB.
Single, you won't be here lah. You create a new DB.
So the new DB only have that timer.
Yeah, of course.
So if you want to change something, like as we discussed before, one PC control 4 tank. If the 4 tank need to add a timer, we just click
Multi-instance.
If we only need one, we
One
only
also
click
can. One also can. Multi also can.
Oh, one also can, multi also can.
Yes.
That means we don't need to key in the timer, they see lah.
Yeah. Okay, you go to function block. Okay, now what I want to do, we want to test this lah, but I want to add timer values. Okay, you go up, go to input out input. Go to the input. Go up all the way up. Okay. In the input, you add a timer in. In the output, you add a timer run.
I mean display.
Display, yes. Then the data type is the time. Yes. Go to your function block. Yes.
How to get another?
Oh, okay. Never mind.
Then one motor.
So many problems.
Yeah.
You bring it up. Okay, go down. Why the timer is in up and in up? Go down. Go down. You right click here. Add row. Okay. You right click at the end here. Cut. Okay, paste it. Okay. Alright, you go up. Go all the way up. Okay, right click the stop. Add row. Okay. You add row lah. Timer in. And the data type is time. Time. Change, you must change. You can time. Yes. Okay. At the output, okay, add one below output, below the motor, timer run. And time also.
So this one timer is under
No, that one is automatic.
automatic.
We don't do any changes there.
Okay.
Okay. Okay, now here it changed to timer in and timer run. go up. Okay, red color, right? Because we add what? Input and output, right? Right click, update block.
I know you coming.
Yes, yes. Okay, now you add timer value here. Put 10 seconds here, and the other one is here 15 seconds. Okay, good. Okay, download first. Okay, so it asks you to reinitialize the data block. Right? Why? Because earlier in your data block, what data you have? Start, stop, motor. That's alright. Now you add timer in, timer out. So that's why it asks you to reinitialize. Okay? Reinitialize. Look.
Now it's giving
Error.
yes, I want to update the block and it's giving an interface synchronize.
Yes, yes, yes. Okay. Yes, it's showing that there's a new added additional input. Okay, 15S, download and test it out.
Now I add input timer set already, right? Output is I don't display.
Time, data type is time. go offline. You add timer value first. How many seconds? 10 seconds, 15 seconds. Add. Then you test and see. Okay, off or not. No. Put timer also you put. Download, monitor, then you test.
Display also me.
Display no. Working? Working, yeah? Okay, now close this one. Okay, now you go to the any DB. Now open. Okay, in the DB, it will be like the list lah. So it will show all the input, output, in, out, and static value lah. Okay, monitor. I can monitor also. You click start. Can you see? I can see the motor through, right? Timer running, and after 10 seconds motor off lah. Not this. Okay, can? Okay.
We don't need to see from the right PC.
So now we see the actual function of data block. Okay, now we want to see actual function. Okay, go back to the main. Okay, go offline. Moses, you okay? Why we do this one? Go to main. Okay, now you delete this timer. Okay, now what? This timer only, second timer only, first timer. Now what is the value? 10, right? So you delete it, correct? You need to download, right? Download first. This will bring it down. Monitor. So the first motor no timer value, right? Okay, you start first motor. How can it run? You deleted the timer value, right? But it still can run. How many seconds?
15.
Yes. From where did you get?
Oh,
DB.
Yes. So when you key in the value just now, see still the 15 is still there, right? So when you key in the value, whatever data you keep inside the block here, all the value will be keep inside the data block. So when you delete something, so when the value is not there, so the previously you key in 15, right, is already in the data block. So when the block is running, the block will use the data block, whatever I said in the DB value. That is the function of the DB. DB will whatever you key in the function block, it will keep the data.
They mean no matter how we delete all.
No, it still can change.
Okay.
Can go to the DB and can change.
Yeah.
Yes. No, not here. DB1, right? Okay, monitor.
Monitor.
This one 15, right?
Yeah.
Okay, now you change here. 10 T hashtag 10s.
T.
Yeah, T hashtag 10s.
10.
10s.
10.
Enter. Okay. Now load start value as actual value. Yes. Can it become 10 seconds?
If I don't want to use already,
Then 0 lah.
make 0 lah.
Yes, make it 0.
Okay.
Now you understand the DB function? DB function, huh? So whatever the function block I key in the function block, the DB will keep all the data.
It means the previous data.
Not previous data. Whatever data you keep, it will keep. If you delete, of course lah, it will use the previous data lah to run.
Okay.
Just now I delete the timer.
Yeah.
So what happened? It used the previous data
Okay.
to write. Because I didn't key in, you know why it can keep 15 seconds? Because I deleted. I didn't change to 0. If I change to 0, of course the DB will follow 0. But just now I deleted that. That's why it follow the, because there's nothing there, no tagging, no value. So I follow the previous one. Okay? You cannot do this in function block. Right? So that is the main difference between FC and FB. Any question? FC, FB?
Can we say like FP is good for if you do any timer? Why not? No.
PLC is also good.
Yeah, FC is very
Very simple lah. FB is good to use if you want to use for repeating system. Okay, which is the value is very important. Want to keep the values. FC is if you want to use for one time can, if multiple time also can, but no, the value is not important. Only to keep the values, the datas lah.
Or like only for the function.
Yes. Okay, can. Take a break. Then after the break, FB done.
That means before we before we create the before we create the payment block, usually we have to start from FP either. No, not necessary. I know it's not necessary. If we need to use FP or FC, we have to create our own first.
Yeah.
Okay. That means we have to the flow chart.
I don't know. We will have flow chart, but we can design lah.
Yeah.
So because of course we will be using subroutines. Like yesterday the FC yesterday we use. That one we call subroutine. So right, we will use that FC. Of course we will use FC. Then any process you see suddenly you want to use a code block. So when you come to code block, you can decide whether you want to use FB or FC. So it depends. Okay. The value all not important. There's no much value. Just normally open, normally close, timer, all this counter, all FC.
Just one like FB just now you mentioned right, we need to keep all the data like for example, we need the output. We need the output like for example water. How many pass through already? So inside the block, we can create a lot of the calculation.
Yes.
And also the input output whatever we want, like the sensor.
Yes.
Like the what you call the timer, and also like something like this. Like the trip. Trip calculation.
You don't go there.
Yeah.
Very simple. I give you example. Yesterday we did calculation for the motor, right?
Yeah.
I mean, I have a counter. From counter output, then I do the what?
CPU or CPU.
No, I do the counter CPU. Then from the counter I divide.
Yeah.
Divide I get what?
Cutter
And also the total and also the balance, right? But inside there got so many calculation, right? So some I can use as a inline input. Some is output. Some is a static only inside there. Some is a temporary only. You can try one. Later we can try one. Okay. So you can. That one also is an example. So that one is up to you. You want to use FC also can. FB also can.
And also one big project. Few people.
Yeah.
All create. Like we discussed, you create FB, you create FC.
Yes. And sometimes it's a similar like analogs, right? Analog are universal, all same. So what I do, I create one block for me. I keep for the projects lah. So whenever the project I need, I just export, import, and I use it. And I can lock the block. That is another thing I forget it. Why they use? I can lock the block. Lock. Yes. Password lock.
So I need to take from you. How to lock it?
Go offline.
Like the PC, I mean how we set the password in the
That is whenever you open it, ask you to put password, right? That is for PLC. This one for the block. So let's say you click on block motor controller, you don't want other people open. Right click, know-how protection. Okay, you put password. Make it simple password. 1, 2, 3, 4, 5, 6.
1, 2, 3.
Then you forget this, then you forget lah. Okay. Created. So if someone want to go and see your logic, cannot. You open.
I open.
Ask you to push button.
1, 2, 3, 4, 5, 6. Okay. The PLC, you see, I create a new, for example.
No, wait. That one later.
Later.
That one is the PLC password.
Oh. So later will be.
Yes. Okay, now you want to remove how?
Right.
Can you see? Know-how protection, don't have ready.
Property.
No. Can you see know-how protection? Don't have ready. So can remove password. Yes. So you must close this. Close this. Right click again. I think I must close the. Okay. So must close the block.
Okay.
Now click know-how protection. Okay. Old password.
Okay.
Then remove. if you want to remove the passcode.
You mean the block have to close first,
Yeah.
empty the block first.
Okay. Good. Go for break.
Okay. Just want to check for you. This one, then yesterday I tried to do it, right? We don't have hardware, then we have to change the address. But something cannot change. Now can change already.
Sometime maybe you are online.
Or then maybe we need to offline.
Yes.
Then like we need
Output only.
output
only.
only input.
Yeah, because only the input you want to modify to one.
Ah,
modify to
yeah,
zero.
yeah. If let's say we need to see the output also, we modify it.
No need.
No need.
No need because output how you can see.
Oh.
Ah.
Like for example, if I
output
set
only one can see inside here only, right?
ah,
Don't have the physical but input. I mean, don't have a PLC, right?
okay.
Ah,
So that
output
means
only.
here after I change,
Is this simulation is open? Then
Yeah.
you right click the PLC.
stop first.
No need stop. Just this one don't control anything.
Okay.
Right click the PLC, download the hardware configuration.
This one.
Ah.
So load. This one is start module, right? Or
No, after load, okay, you see, download finish already.
ah,
So start the module after downloading. Okay. Choose start module finish. Then go to your program.
admin,
Yeah. Okay. Now you can modify this to one.
this one.
Monitor first.
Monitor. Have to monitor first.
Yes.
Modify to ah,
Modify to zero now.
modify to zero, right?
Yes. So output no need because output we only able to see here.
If
No
I
need to change.
go to the, I mean I create the HMI,
Mhm.
so output also no need to change.
No need to change. No need to play with the output because the output is the result from your program, right? Only the if you have the physical something then you want to play then it's okay lah. You can change.
And also what is the HMI?
Mm.
We create a button,
Mm.
start button. Go to the event,
Yeah.
then go to the
Press set bit.
set bit input bit. We set the start button. Then
Yeah.
also the release
Release,
we
reset
also
bit.
reset bit.
Yes.
And the color, the start button I need
the
to-
color.
yeah, for the
Okay.
animation.
Okay, correct.
Animation and
Yes. Appearance.
appearance.
Yes.
Open. I put in the start button
Start
there.
button. And
Zero.
What color? One
What color?
Same color. Same you do for the shape.
For the output.
Yes.
But this one like for after the simulation for the PLC, they will link.
Yes.
But yesterday I tried the PLC and also HMI unable to link.
That's one setting need to do.
Because HMI we already created and link like when we open the file, right?
But when you create HMI, you offline the PLC first.
Okay.
Then you create, then you just start simulation lah. You can go to.
他们开心就好啊，你也开心啊，不要每次发脾气啊。阿涵讲哩，阿涵讲哩，无了解。意思讲伊啲都送回来成啦。伊常常伊只反正有一项物件 OK， 伊只我看着迄个小头啦，有一项物件就是start 加 stop 咯。迄个 selector 伊袂敢会使用迄种 selector switch 咯，就是讲爱转去倒手还是正手反正莫像迄个迄个啥物做电反正。伊汝做迄drawing 个迄个 sequence， 就是讲迄个 diagram 是啦，是讲常迄只款诶，就是汝做迄粒 panel 互我，either 我有一粒 timer， 就讲我行 manually timer， 我 select manual 来讲行 manually timer， 无就我去 add auto， 伊一直行 auto 对了 timer，start from 头一粒款诶。伊是常迄只个物件来，无讲无安怎，就是讲迄只是 logger 嘛，那汝是换去 Sony 内把法安尼。Saya pun tak tahu. Saya that's why dulu ada beli satu cuci chemical tapi saya memang lupa beli dengan siapa. That's why you boleh nampak sekarang yang itu Mondelez punya besar ni platform tu. You tengok dia punya lantai sangat-sangat sama color ni. Dia tak ada macam kosong-kosong yang lain. kan enak lu tôi là khi ra không được gì sang em tapi ai so tôi là hoặc tôi nóiว่าchẳng lẽ đi ra con này là chỉ có như là three phase sale thì như là nhập siêu thì có single phase thì chút thì nhập siêu so với nhập bao熊猫女不觉得，sẽ phải thường đến cái sao cũng là sẽ phải thường đến sao cũng là khi他都别啊，我唔知我就是奇怪，真好啲嘅嘛啲，因為白thường tháng gì，我俾，但係我就是唔知道，我唔識佢都俾你啦，咁樣我。tapi 就是袂記去走去哪路買，我就是袂記去了咯。伊毋是 acid 來嘛，毋是講洗嚟 welding 嘅嘛。就是我就奇怪，去哪路買，我袂記去啊！我定舊年有用一道，我就是做迄個白光嘅台子啊。before 你做迄個白光台，我早一道有做一個白光台咯。迄邊我本洗過一道。然後過後，你做啲白光台時，我本來袂記去家己使要人教咯。啊，唔要緊啦，唔要緊啦，幫我想下啫。你把你對本海邊做咗？
我
借。
所謂翻翻上嗰個
特別愛一個來，因為我喺神龍嗰邊，我問你本來攏行咯，一個佇古龍，一個佇神龍嗰邊了。就是伊人有一班佇神龍嗰邊嘅古龍無位做了嘛，然後我是愛等落床來，我買一隻落床，我等落床來先。你別記，你即個月後應該是較有病了是哦。啊，會使，到時候最好我等我落床來先。我問你下落床啦，我是買鐵啦，買到落15M的咯，迄個是真舊了。四粒RAM的，四粒的。啊，對，四粒輪的。啊，就是伊是講會經白光會到12M， 鐵會到15M， 是94啊，是94啊。迄隻好做白光是講特別迄隻會起了有一個負債哦。伊講負債福順買互阿姐嘅啊，伊隻會起了有一個負債哦。特別迄個是3粒的嘛，毋是4粒的嘛。會使，把攞買4粒啦，因為迄隻題有講，你講4粒較應景。啊，伊講免講條電機帶迄個頭係安怎？今仔我等來頭先，我較有知。OK。啊，有啦，大家找我啦物件。OK。 This is the one.
ROG, right?
Ah,
ROG, right? Asus.
Asus, yes.
ROG,
Because this one I bought because of the drawing.
Oh, AMD one. AMD line, yeah, okay.
Yeah. Because I don't know.
Equivalent to i9 this one, processor.
Then they said, this one better. Then I didn't buy lah. Because
How much is it?
2 years ago. Now I heard it's around 10,000 maybe. 2 years ago I bought 6,000 plus only.
6,000. Now 10,000 because of the newest general.
Yes, correct.
They not really soon because they keep increasing the price.
Yeah, because AMD lah.
They keep on getting heavier.
That's why they say, oh, you luckily buy 2 years ago.
Yeah. Asus, this is Asus, right?
Asus.
Acer one got another one, but this one got SSD got more, how many slot?
Another 1 slot, 2 slot.
Minimum also 2 slots.
2 slot lah.
The Acer I bought has 3 slot.
Oh.
3 slots, so more storage I can put in lah.
Yeah.
And maximum I can increase to 64 GB.
At the time I planned to buy the ThinkPad, they said ThinkPad only like for office or something.
ThinkPad. ThinkPad Lenovo.
Yeah.
Lenovo ThinkPad like that lah.
Yeah, correct.
For coffee,
Actually ThinkPad is ThinkPad for office use also can, but ThinkPad the highest spec one can
Oh, yeah, what
his one also ThinkPad, that one is the highest one lah, that one is the heavy spec lah. That one is the heaviest spec. That one you can install all the PLC software inside and you still can be able to take the
At least we need to open all of the window, right? Check on that.
that one, whatever we have over here, all second hand one, because I know how to maintain. But you want to install any PLC software like TI portal or already, because that's your personal laptop, right?
Not this company.
Company laptop then install a personal mean I won't recommend. You use VPN. VPN lah for the virtual machine. You use virtual machine. But you use virtual machine open up because if you use virtual machine you need to increase your RAM.
Yeah.
At least have 32 GB RAM. So you can allocate at least 8 GB for the virtual machine. 8 GB and then at least 240 GB storage for the virtual machine, then install the TIA portal over there. Because if anything goes wrong, if the TIA portal become buggy, installation is very straightforward. They want you to install the software in your system, or want to uninstall a thermometer. Want to uninstall. Some of my clients from Shopee, they say become buggy already. I tell, okay, you just bought a TIA portal. Okay, let me see your system. See, you already had the TIA portal inside. So if you try to install another version of the TIA portal, it might clash. You might receive some sort of error and maybe some net framework error. And then you can uninstall format your laptop
Format only. Nothing can.
Format your laptop, don't waste my time. I want to go through and uninstall one by one. In 2 days also won't finish one.
You really have to check one by one.
Installation very straightforward. Uninstall must do it one by one. Come on. At least give us a separate software just to specialize in uninstalling TI portal automatically. They won't give. So that's my advice. Uninstall this type of heavy. The CX programmer, GX Works 2 or Keegan software. That one all I used to call it as a lightweight software. But this TIA portal, this RS Logic, Control Logic, Studio Logic, these are all heavy type software. You want to install that, just use a virtual machine and install. If you install in your personal laptop. Okay. Before, just double check for me your name and IC. We prepare the certificate. Mr. Lee. Just double check. And then just pass it to me back and tomorrow I will. Yeah, double check your name and IC. All okay, good. Okay.
Cái gì của người lớn gì? Nè, lấy cái một xuyên 你还没有星期三还是星期二问到你现在了，你还跟我讲你还
要不 level
对，yes， 这样子我就很担心啊，我妈那个时候我去哪里，你们的 display 找不到。那就是现在很多我的第五嘛，对不对？你闻一下，因为那个年头到现在还没有半年什么都没有，到底真的在等我录你吗？好，应该是那个宝宝那边就不用了，我是不知道，而且有点他们的 FD 所以年头摆在去的怎样啊？change back 哪里知道？你们不是听着的咩？
Where you want to change? Okay, there's two options lah. One, go inside here. Go inside here and change
上文啊，不是 acid 啊，不是 acid 啊，上文来的，就是洗的啊，不是说放在那个 welding 那边，不是那种的啊。
Okay?
它是，好像是洗啊，冲洗，它不是洗 welding 的地方的啊。对，
Override ah.
来，我就是挤很久啊，对不对？哦，那个不是，那个是羊毛，我是讲那个萨文。
But not,
Some will do
no
the acid
problem
lah.
lah. DB like this also not issue. Most important.
不是 acid 啊，你地方 acid 是羊毛啊。
FC, FB all must be green colour.
啊，不是那个东西啊。啊，你今天有跟我，你找 Mus， 你找 Mus，
So we use the same
你
project.
去跟他谈，教他这样子做，因为我有一个白钢的那个塑口面的那个桶要洗，我一直找不到那个扫把。对，你有打电话吗？你没有见过他，那有可能啊。你只要楼上那几个罢了嘛，你不要楼下不要去理啦，楼上就可以了嘛。不要说那个我那个，因为我是跟你讲楼上你不用去理的嘛，你要去不要理楼上，不要理楼下啦，楼下是多人，楼上是不多人，你看楼上人就可以了嘛。法迪拉，现在法迪拉给你order还不是？
The side,
my
slide show.
要是有赛事，就是那些。
对。OK 的。
Yeah, we see. Very nice. Go down. Go down. Okay. Analog. Okay. So analog inputs, right? Analog means is what? Got range. Okay, analog means range. So we have input and outputs. Okay. So for example, like input and output, we can measure in 0 to 10 volt, negative 10 to positive 10 volt, 0 to 5 volt, 0 to 2.5 volt, all gone. Okay. NPM means 0 to 20 milliamp or 4 to 20 milliamp. Okay. So this one we connect to the PLC. So for example, like this like pressure transmitter like this. So you can see the range here inside here. So for 20, it will measure 0 to 250 millibar and the range is 4 to 20. Means if you receive 4 milliamp, it means 0. If you receive 20 milliamp in the PLC means it's a 250 millibar. Okay, that is the range of your the instrument. Okay, the instrument. Okay. Next, how it works. Okay, so whether it's a pressure transmitter, whatever transmitter, if you go to your option board or expansion module, or your PLC right already have a built-in analog input, right? Correct. Your PLC built-in AI.
Go to AI.
Okay. So you connect this number 0 to 10 volt, 0 to 5 or 0 to 20 for 20. In your PLC, you will get this number. 0 to 27648. It's fixed for Siemens. All the Siemens are same. 300, 1005, 400, 8200, all same. Okay. Then, so it means how it works. So this is your CPU. This is your AI card, right? AI card or AI module, okay? This is your transmitter, okay? Let's say I measure 0 to 100 degrees Celsius, for example. I go to PLC, so the transmitter will convert the temperature value into 0 to 10 volt or 4 to 20 milliamp. This is the common one. Okay. Then the AI module, the function of AI, convert analog to digital value. Convert analog to digital value. Digital value means that the 0 to 27648. Okay. That is the range. Means okay. If you are connecting 0 to 10 volt, your AI must be 0 to 10 volt. If you are connecting 4 to 20 milliamp, your AI must be 4 to 20 milliamp. So it depends on your AI analog input. Okay. So what I need to do is so this is your AI, which is 0 to 27648. I need to convert to 0 to 100 degree. We convert to a temperature. So at the, for example, at the system is 100 degree. Your transmitter will give you 20 milliamp. In the PLC you get 27648. So the programmer, what the programmer need to do? Programmer need to convert this into this. Then only we can know what is the temperature value. Then only we can show in the HMI, or we can use for some calculation. Okay. So how to convert? This is a linear scaling, right? So what is the formula? Y equal to mx plus c. So yesterday we do this calculation max function, right? So find the m. So how to find the m? Y maximum minus y minimum, x maximum minus x minimum. You will get the m. X is your analog input. C. But for now only C lah, because it's direct here lah. So sometimes we start from here. Okay.
You mean 4. C is like 4 or
4 milliamp or something like that. Y min minus m multiply x min. So you calculate the m first, you calculate the c, then finally you calculate this. To get the y lah, the temperature. Your x is this one, your m is from this calculation, your c is from this calculation, x is your analog input, then you can get the y. Okay? But you don't need to do this calculation because Siemens already have a block for you to do the conversion. Just use the block, just key in the necessary data and get it over. Okay? So the block is norm X is a normalized, they call it. Okay, put it here. Norm X. Okay. Norm X is okay. You need to choose the data type lah. What is the data type? Okay. This is the minimum value maximum, and here is the out. Then once you finish this, then only we do the scale X. Okay. The minimum value maximum. Okay. Up. So this one, you know, when you do calculation, right, you will have the data type to choose, correct? What data type? Whether it's integer, double integer, real, right? Same. Here also need to choose for the norm-x scale X. So when you do for analog input, your analog input, is it integer or real or what? 2764, right? It's an integer because analog input. So I choose INT, and here must choose real lah. There's no choice. Must choose real. Okay. The same thing here. Okay. Then this is the output. Output is your y-axis. Okay. Your y. So it's depend whether you want the temperature in real or integer. It's depend on those who want to do that. Okay. So how? What is the data here? Okay. The value must be your X. I didn't do I put like a common one. How it works. Okay. Your value is the X axis. Your X axis is what? AI. So put the AI. Okay. Then your minimum is the X minimum, X maximum. Okay. This is the output lah. So I just put norm X lah. Norm X. So the value must use the same thing here. Norm X, the same thing lah. Okay. This minimum maximum is your Y min, Y max, and this is your Y axis. This is how you do the scheme.
X is the analog input.
Doesn't matter because later for this is analog input, because later when you do for analog output, your analog output will be your Y axis. Later. Okay. For now, so your X, according to this, your X axis is what?
Oh,
AI.
Input. X is
Okay.
input. X is the analog input. Y is the analog.
No, you don't put that way.
No.
For this lah,
Mm.
then when you do the program first. Don't come to a conclusion. Because later with the same thing, if you do this, because for analog output also, you will be using the same norm X scale as well. Okay? So norm X axis, when I do the graph for the analog output, your analog output will be at the Y axis. Okay, don't think, just focus here only. So it will be in the Y axis. So if you tell me X axis is input, means the statement is wrong. Because for output it's a different one. Okay, so just based on the graph, we follow this. So whenever you do a scaling, you do the graph first. Okay. So now here I put the y-axis is the AI because we get this value. Right. I want to convert to this value. Okay. That's what we want to do. Okay. Okay. later we see. When you learn for both analog input output, and then you can come to a conclusion. Because I know always, if you come to a conclusion, then you do mistake in analog. Okay, can? Because just for example, if you analog output, the graph will be like this. For example, this is my set point, this is my AO. So 0 to 100. This one 0 to 27. Okay. This will be my analog output in your scaling. But later we see how it works. Okay. Now, my x-axis is AI or AO?
AI.
So that's the point.
No, cannot fix. Why cannot? Because you see, for analog input, x-axis is AI. For analog output, x-axis is no set point. Got it? You see, for y-axis, for analog input, for y-axis is what? A temperature.
Okay.
It's a value, right? The result. But y-axis in analog output is AO. Correct?
Can we say like Y is a figure, X is a figure to convert to Y?
Yeah, of course that is true. That is the function of a graph, lah, right? So we get the X, we convert to Y. That's the function of this. So don't fix x-axis is an AI or AO. No. I have a value, I want to convert. That's all.
I need to come out one value.
Yes.
And
So from x-axis, I want to convert to y-axis. So you just remember that it's okay. Whatever here is the x value. Whatever here is the y value, your y. That is, if this one will be easier for you to understand. Because the graph can be x, y, it can be different.
Yeah. If let's say we only have the Y, but we need to get
Cannot.
X.
How cannot?
Sorry.
Won't work.
That's why because we only can like start
From x to y, yeah,
to Y
of
only.
course.
But Y cannot do X.
Of course.
Like they maybe have the result, but we don't know the X.
That one if we can manually want to calculate, we can calculate lah from the y to x.
But
PLC is of course from the x to y calculation. Okay? Okay, now we go for analog input. Okay? Okay, now what is our PLC analog input address?
0 to 10B or 4 to 20.
That is our value. What is our address? Address.
I use it.
I. What address? Where to go and see?
Our
Usual.
No, you go and see. Where to go to check the my PLC IP address?
the soap tag.
No.
Not the tag.
No. Where to go to check PLC addresses?
Device configuration,
Okay. Go to device configuration.
and then you pull that.
Pull this data.
Yes.
From here only we get the address, right? Correct or not? This is where I get the PLC addresses. Okay. Now what is my analog input address?
64,
64. Okay. What is the address? You give me the complete address. I what?
I 64 on the EQ.
Okay. I 64.0 means it can store. It's a boolean, right? It can store what value? It can store what value? It's a boolean. Boolean means only can store 0 or 1. But my value is 27,000. So where to store?
W.
W. So what W?
It's an NW.
No.
No, IW.
Yes. It's the input, right?
Oh.
So our input is salah IW64.
Okay. That means the B, B, W, D is not necessary we need to put M. Man is memory.
No, no.
We can.
That's why the day, yesterday itself or day before itself, I said MW, MD, this one all apply for I and Q also.
Okay.
Correct. I told you because remember that day I write Boolean means okay what?
Yeah.
By so I put here I just put M only, right? But at the same time I tell you what I also Q also DB also apply the same rule.
Okay. Let's say like we use IW64. We need to change to M.
Want to change to M?
I mean the M. I mean the next we need the memory MW. Different.
M is of course M numbers is different. I numbers is different. Q numbers is different.
So that means we don't need.
Each one they have their own range.
That means we don't need to follow like now IW64. The next cannot be like MW68.
No, that is different. Memory is different numbers.
Okay. That means I is different number. Q
Of
is
course.
different number.
Did you okay? You asked me this question, right? And now I ask you this question. When you use I 0.0, did you use M 0.0 or not? No. You use right M 0.0.
Yeah.
Correct, right? So means you didn't think of clashing, right?
Yeah.
Because why? Because M is different, I is different. Same thing for word also same thing. So I address I have until around 1000 address for I. For Q 1000. M I have 4000 plus. DB I have 32,000 plus. So each one they have their own range. Okay, good. Okay. So here IW64, but why until 67? Is it ID? No, right? Cannot be ID, correct?
IW.
Must be IW. Why? Because our analog, all PLC analog always 16-bit. Okay? But here you see 64, 65, 66, 67. Why? Because I have two words. Correct? Two analog input, right?
Yes.
Two analog input means it's a two word. So IW64 and IW66. But why they show that until 67?
66, 67, what?
Yes. So what they are showing here is the byte number. They are showing I start with byte 64 until byte 67. So later you want to add anything, must start from 68. Automatically, of course, automatically. Because even if the first day we learn add the module, right? What happened? 0 already used. So start only from 1, 2, 3 like that. Same. Okay? Clear? Good. Okay, now what you do, I give you this analog injector. This one can inject 4 to 20 milliamp or 0 to 10 volt lah. Now, my analog input in what range? This analog input right is what range? Okay, you see at the side here. AI
2 times 10 bit 0.10 0 to
0 to 10 volt. Okay? Can see very small. Very small.
0 to 10. If let's say we buy the sensor like the transmitter is 0 to 10,
Then can directly connect lah.
then no need to convert already lah.
No need to convert. If 4 to 20 milliamp.
0 to 4 equal to 4, 10 equal to 24.
Yes. 24, 10 volt.
Yeah.
Okay, so now this one you have a ground and 24. That's to power up. Ground is 0 volt, 24 is 24 volt lah. So you can use this to power up. Then another one is a ground AVO, analog voltage lah. So the ground you connect to the 2M. 2M is the common lah. Then the AV0 connect to the first input 0. Okay? So just power off and you can connect.
Something.
You can ask many questions, no problem. Oh, they have.
Siemens is common is 0 or 24.
No, all common is okay. You don't need to specify that. Common is 0. No.
Yeah, I want to just like fix it.
Okay, normally some PLC they put is a 0 volt.
Yeah.
Some PLC but not all.
But this one we put this one.
2M, right? We
Yeah.
put M.
M.
Okay, you see. You remember that day when I draw that one, I put L plus means is 24 volt.
Yeah.
M means is 0 volt. Okay. For Siemens, M means is fixed, always 0 volt.
Okay.
Only for the input 1M only can be both.
Okay.
Because actually they're supposed to put that
Yeah.
COM, the name COM. They cannot fix like that because it's confusing, correct or not?
Yeah.
That's why I'm so confused.
Yeah.
Why M? Then I always follow 0 volt only. Then once I go to the manual and see, it shows you can connect sync and also source also can connect.
They mean both lah.
Both also can. So at 1M it can be 0 volt or 24 volt. Only that. Only the input M lah. Other than that, all the M is 0 volt.
Okay. So that means here we didn't put because of M. M1 lah.
This 1M, right?
One.
This, I mean very simple lah. The input M.
Ah.
The input M can be 0, can be 24.
But here the
The
M.
other M all is
Is
0
0
volt. Yes.
All like Omron also. Omron is a comb.
Okay, Omron, if it is 0 volt, they put 0 volt.
Oh.
If it is can choose, they put COM. You can see here.
Yeah.
We put you see negative mean negative, right?
Yeah.
They
COM.
put COM. So COM means can be 0, can be 24. Common.
Okay.
Same like the 1M there.
Okay, one thing plus here is a 24.
Yes.
So 24
Yes.
here must be 0.
Yes.
So here either you put 0 or 24
Yes.
to control all the input.
Yes.
The output must, if let's say here is a 24, here must be.
No. Not must be. Can be anything. Different.
They mean here 24, here also can 24.
Can is not must.
Okay.
Correct or not? It can be anything here. Okay, the output can be any voltage. Input is depend on your sensors, whether it's NPN or PNP sensors, right? Positive or 24 volt. Input and output is not related.
Oh.
Don't always think okay, input 24, output also 24. No.
I understand. That means the output is the output.
Output is the output.
I don't
Input
want
is
to
the
know.
input.
Input I need to know. What is the sensor I need to buy?
Yes.
What is the input you give me?
24.
Either 0, if let's say your COM is 24, in is 0.
Yes.
Okay.
Okay. And different PLC, different style. That one you need to understand. Okay. So like this, give me one.
That's why.
Sorry. The adjustment. See, different PLC, different style. It's a DT. I don't think so. I have. Mine is all relay type lah.
That's why because they say the Omron is more easier to understand.
All PLC easy to understand.
For you it's really like for us. We are new. Maybe we have to find the easier way to understand this one.
No, the thing is, you know what happen is, you whenever I give you some example, you try to not link, memorize that. Oh, input means okay, this. No, try to understand the concept first. The concept, okay. You see this one, okay, there's two type, right? Okay. This is a relay output. R, right? The relay
Relay
output.
output.
This is the transistor output.
Transistor is
Okay.
I don't
No.
know.
No, sorry. You listen first.
Okay.
Okay, so they have another model T1.
Mm.
So I don't have that model.
Mm.
Okay. Relay means, just now we understand your input, understand right? Now we're talking about output. Okay, relay means, this is a relay. Relay means whatever I connect at the COM, that will be my output.
Connect to the con.
Like a relay, right? You know, you understand relay, right? Relay, how the relay work? You forget about the coil. Contact, whatever you connect at the contact, that will be normally open, normally close contact.
Yeah.
The same concept. Whatever you connect at the COM, that will be your output. Let's say at the COM you put 0 volt. When the output energized, give 0 volt. Okay? If the COM is 24 volt, when the output energized, give 24 volt. When the COM is 230, okay, it's a relay, like a relay contact. How you work with the relay contact, that's how it works.
Whatever value will be same value.
Yes. So the coil means it's inside here lah. Like a relay, this is the coil.
That means
Then how we know that? Let's say this one is the
No, we don't talk later. We finish this first.
COM. COM is like we give the signal. Signal come out 0.0. No. I mean like this COM is 24 volt. They say okay, for example, we set this like output 0.0.
No. We don't talk about the addressing. We talk about the voltage, right? We talk about the voltage.
Okay. How to activate this voltage?
No. If the output energized, it will activate what?
Okay, if output
Energized. Okay.
which one will be lighting?
The zero. The zero.
0.00.
Zero there.
COM?
No, COM is the one you give.
Oh.
That's why I say.
Okay, that
At
means
the COM you give, that will be your output.
okay, that means we always supply the COM
Yes.
24V. Then here will be energized if
No.
Okay. Not energized.
You give me
we-
finish your statement.
we want to, if let's say we want to on output the
No.
zero,
Who on the output?
we are this PLC.
PLC on the output.
Yeah,
Okay.
PLC on the output 00.
Okay.
So 00 will come out 24 volt.
Yes. At the COM, you connect?
All the 24. If
Yes.
they said 0, they mean the 0 come out also 0.
Yes.
They mean
So
keep
we don't
supplying
talk about zero lah. You just tell output.
output.
Easier.
That mean the here we always supply.
Yes.
See what we supply.
Yes.
Either 24 or V. So they will stop. See, depend on the PL.
When the output energized,
come out.
Give me back the voltage.
Yeah.
Correct? That is the relay type. Okay?
This is the relay type.
Relay type. Relay type means at COM you can connect 0 volt, 24 volt, 230.
Sorry. Yeah.
Input also the same.
Input different. We're talking about output. We talk about output. first.
Okay. I have one question. Sometimes I see from my panel, right, they are using Omron. Okay. But I saw a lot like they give the 0 voltage and also the 24 voltage. Is it the relay type or what?
No. Okay, relay type. Yes, relay type.
Okay.
Because you see, this, can you see a thick line here? Means if you give 0 volt here, the 0 volt only go to here only.
Okay.
It's output only.
Okay.
This COM is for 1. This COM is 2 and 3. This COM is 4, 5, 6, 7. So can you see different COMs? So let's say my first lamp I need 24 volt. The first lamp. So at the COM I connect 24 volt. When the output energized, 24 volt go to the first lamp. Let's say second one is a valve. It's a 24 AC valve. For example.
24
So AC. So I connect here 24 AC this COM, and this output I go to the valve.
Okay.
Understand?
No.
Not understand.
Understand.
Okay.
Okay. We have
Okay, what you understand, you explain to me.
Okay, we have this one is the comma.
Okay.
Depending on 0 or 24 volt.
Okay.
Okay, let's say we supply 0 or 24. Here is our output. Our output. Let's say our output, we have a lot of output, let's say 24 volt, 0 volt.
Okay.
Or we have the milliamp or
No milliamp.
milliamp
24, 0, 230.
230. So let's say we supply 0, then how about coming, because since we have 230, 0 and 24.
No. Okay, first, this one you understand, this thick line, you can understand? It means this COM only work for this.
Okay.
This COM only work for this. The one you understand?
Okay.
Clear?
Clear.
Okay. Means This is a relay type. Relay type means whatever you connect at this COM, that will be my output. Can you understand my statement? Means if I connect 24 volt,
Okay.
when the output energized, I get 24 volt. Okay. When I connect 0 volt, when the output energized, I get 0 volt. When I connect 230 AC, when the output energized, I will get 230 AC. Can? It depends on your field device, what to connect.
Now I one question. We call it a COM and 00 lah. One cable. This is a lighting. Okay, this is not the button, this is a lighting. Output is the lighting, right? This one is a 24 volt. That means this lighting I need to link to COM. And 0.0 go back to here.
No.
No. Okay. Then how to activate it?
How to
Yes, my question.
Very simple. How to activate a lamp?
Yup.
How to activate a lamp?
Don't know.
Okay.
No, normal lamp. How to activate a normal lamp?
On.
What supply you need to give to activate a lamp?
0 or 24.
Plus minus.
Yeah.
Very simple.
Oh, okay.
Yeah.
We talk about plus minus. Okay. So this is a power supply. The minus will direct go here.
Okay.
If I take the plus direct go here, what happen? Lamp on.
Okay.
But I want the PLC to on the lamp.
Yes.
Okay.
So what I do? Minus go here. Okay. The plus will go to the COM.
Okay.
When energized, the plus from the 00 go back to the lamp. Got it? Like a relay.
Here, here, here.
Okay.
Okay.
0 is keep supplying the.
Yes, keep supplying. Once I get 24 only, the light can light up.
That means 0 and 24
Yes.
must be together.
Of course, like that's how the light works. Positive, negative, like a battery.
Yeah, like the live
But-
and the neutral.
Yes, positive, negative.
Oh.
That's why I use the term positive, negative. Very simple.
And you mean live, you cannot line link together, then how to on the
No. If light direct connect means the light on already what?
But without the neutral lah, let's say without the neutral.
With the neutral, of course, they cannot.
Okay, mean okay, now we link one neutral over here already. Here live link to this
0.
0. The COM come out.
No. We talk about. That's why I say. Okay, you see, this is my power supply.
Okay.
Understand? My power supply.
You use live and neutral.
Yeah.
Okay.
This is my power supply. This one need live and neutral to power on.
Yup.
The neutral I direct connect.
Ah.
The live from here must go to the COM.
Okay.
Okay. When output energized from 00, I go to the lamp.
Okay.
Okay.
Got it?
Got it.
Can? Okay. If this is a 24 volt lamp, same thing. The 0 volt go here. The 24 volt go to the COM. When output energized from here, I go here.
Okay. Can we say like now is 24 go to here. 0 have to go to here. Come out is a 0.
Can also. So now you understand this or not?
Yeah.
How this one works?
Yeah.
That is the relay type.
Okay.
Okay. If a transistor type means the output is fixed, cannot choose.
Okay.
Now this output can be
Choose.
0, can be 24, can be 230.
You just switch the.
Depend on what is the COM.
Okay.
Right. But in this from this one is a T, right? They have T and T1. T means it's a 0 volt. Means at the COM you only can connect 0 volt. And my output is always 0 volt only. If a T1 at the COM I only can connect 24 volt, my output will be 24 volt only. That's all. Means it's fixed.
Yeah.
T and T1 is fixed. 0 or 24. Only the relay can choose anything.
Okay. Then for us easier by this.
Yeah.
Fix. We fix it.
Different.
But yeah, we fix it.
Yeah, like that also actually same. It's
But you know how to see.
No, it's not confusing also. Why you confused? The output, right? They tell what?
Oh,
It's
24.
fixed. Means it only can give you 24. So that this one no COM. I mean this is a Siemens style lah. We cannot. This one. So it's a Siemens style. So they already give you. They tell you 24 volt. So they ask you to connect L plus and N, right? To power up the system for the output lah, to get the power. Okay. Then that's all. Your output always will be 24 volt.
Okay. So
This
that
one.
means the L is a 24.
Yes.
M is a 0.
Yes.
Okay, then they power up here already.
Yes.
So all the output 24. That's
Yes.
it.
Yes.
Then your sphere, you have to connect 0.1 something.
Yes.
Have to.
Correct.
Then,
Okay, clear?
okay, clear.
Okay, this one is
This one is power supply. Here is power supply.
this one to power up this lah.
Then here is
Analog for the analog.
analog.
Mm.
This one we connect to the input. How about this one?
This one is to connect to the 2M. Got 2M right? The ground.
Yeah.
2M.
Here.
Which one?
No, the analog got 2M.
Oh, wait.
Because analog always positive negative.
Okay.
Correct.
Yeah.
One positive, one negative. So here the ground is negative. This one is the positive.
VA 0 is positive.
For this line positive. So on your this side is the 2M is the
Positive.
no 2M.
Negative.
Yes. The 0 is the first one. Positive.
Oh. Okay.
Hmm.
L, if like, let's say, okay, we call it this way. L plus, we already put the 24 word.
Yes.
N must be 0.
Yes.
Because we need to open up this.
Power on the
power
PLC.
on this.
Yes.
If let's say all N is a 0,
Mm.
that means 2N also is a 0.
Yeah, of course.
So 2N have to connect 0.
Yes. But 0 from the
Ground.
system. I mean from the my instrument. My
The bottom
transmitter lah.
also same.
So the input will be
3N is a 0.
Yeah, of course.
Plus is the 24.
Yes.
Oh, okay.
Can.
okay.
That's why based on this one based on this one
yes.
if let's say your L, let's say is 0, then your M is 24. Cannot.
yeah.
Why?
Will be-
Because they already give you what positive, negative what.
Will be plus.
Example lah like this.
Yeah.
Positive, negative, right? Can I connect here negative? Can positive? Can it work? Cannot work.
They been fixed already. Here is a positive,
Yes.
here is a negative.
Yes.
Whatever negative, we all follow negative.
Yes.
Positive follow positive.
Yes.
Okay.
Can?
Can.
Easier.
Yes.
We don't need to know how to read this.
Okay.
Okay, you do the wiring. Power off and do the wiring first.
If let's say we see from the sensor, 24V definitely is a 24. We call it 24, right?
Yes.
G
Ground.
ground.
Ground is zero.
Any other to represent if let's say there is without any 24V?
No, they just put. Normally they put 24. In the instrument normally they put 24 or L plus. Something like that.
They need L plus or 24, always 24.
No, that's why I say we cannot fix because in Siemens L means is 230 AC.
Yeah.
L plus means is 24 DC.
Oh.
So it's everything is based on their respective brand and instrument.
So for us, it's easier. We buy the thing,
You need to read the manual.
to be the manual.
Data sheet.
Then after that, the next project all the same.
Yes.
No need to change. Don't make it confused. And sometimes sometimes I also check the cable. Wiring I also familiar. So we need to check whether the cable is it linked or not linked. We need to check in this way lah.
Yeah. This one need to press the button.
How do you know?
I think to press the continuity button. The sound.
Oh,
Okay.
nice，那个产品，
啊，这个只是就是要看你的 cable 有没有连在一起，这样子是没有连，这个是24V 嘛，这个是0嘛，所以 M 是0嘛，所以它是没有连，一个是0哦，如果你去 L 这边它就有连起来，第一个，这样子就是说哦，这个是对了的，因为 L plus 是24V 嘛，现在放在24V 是对了咯。如果你去动 M 的话，你就放24V，你看它是没有亮的，没有的啊，这个不算。所以如果你要检看 M 对不对，放在这个0这边，
那个地方，
就说哎对啊，这个就是0，这样子。所以这边 M 呢，也很简单，就是你把它这个M 看有没有，
这一个 M，
第二个 M
这一个 M，
对。就说哎对啊，因为这个 M 是0嘛，所以它两个是对了。
这样子的话就是
不能，因为这个是input，这个是 analog input，它不是 supply。
这是 supply
不是。
Because sometimes I check, if my cable, this is electrical, you know the problem.
Yeah.
If my cable on, but I measure cannot be on, but we don't know whether inside on or not. How to check?
How to check it?
That means how to know the cable is on.
Okay, so for example, just now you're testing, right? Okay. Let's say at input one terminal block. From this terminal block, go to my PLC input, right?
Yeah.
Okay. So you just check from according to wiring diagram.
Yeah.
In the wiring diagram, they will check. Okay, this is the terminal block number 5.
Yeah.
Go to the PLC
Number 5.
output number 5. Okay,
Yeah.
any number.
Yeah.
So let's say 5, right?
Yeah.
Then you check. If you can hear the continuity sound, means it's connected.
Yeah.
If not, it's somewhere is break or cable loose or something. So what you do? Just tie the cable at the both side, you test again. Then no problem. What you do? You remove, cut, strip again, connect both sides, strip again, check. Or you remove the cable, strip, new cut lah. Then you touch the cable. Just now you touch the terminal, right? Touch the cable. If can't, is okay. If no, cable break.
Now is the cable is inside the panel lah. If they say the cable is a toilet there, one panel is over here, another one panel is over here. How to link it? How to get?
Okay. In that question, what you can do is
We cannot like pull the cable.
can give like check the voltage lah.
Voltage.
Means okay. Is it the what sensor cable?
Yeah.
Sensor
Sensor
cable.
Okay.
Say from here to here the sensor cable, right?
Yeah.
Sensor is here.
Yeah.
The cable is connected at
Yeah.
the panel there lah. Okay. So of course sensor will have 2 or 3.
Yeah.
Sure it will have positive, negative.
Yeah.
Sure when the sensor trigger, sure can give you positive, negative.
Yeah.
So you trigger the sensor, you check the voltage, get 24 volt or not. Touch on the positive, negative and check.
Maybe we have two
No, not 1 millimeter. 1 millimeter at your system,
Yeah.
at your panel.
Yeah.
Trigger this sensor.
Okay.
Just maybe it's proximity sensor. Just touch a metal or something. Then because some sensor can see the light up, right?
Yeah.
Then you measure the voltage.
Okay.
Okay, so you can know already whether I can receive the voltage or not. Okay, number 1. If let's say just a cable only,
Yeah.
So if you adjust the cable,
And also we don't know is it that cable also correct or not? Is it that
that one
cable?
is according to wiring diagram, you need to check lah.
I mean like for example, this is sensor in the field. There is a cable, maybe they mention is for this sensor,
Yeah.
but maybe
Not
not they mix or terminate wrong. Like, yeah, correct.
Hmm.
How to check it?
How to check it?
I think another thing is all the proximity sensor they have a little LED light at the far end of it.
Yeah.
When it detects, you can see there's a little light.
Like
Yeah,
I know they have.
You can remove that. If you are not sure if that's a cable, you can remove the 24-volt supply on the panel.
Okay.
Then you come to the sensor and you check. You activate and see there's light. on.
Yes.
Then maybe we have to check one by one.
No, what it mean is
Okay, let's say we have the 10 sensor.
No, yes. What it mean is okay. Of course, the sensor go to your input,
Yeah,
right?
yeah,
But you don't know which sensor is the which input.
yeah.
Right. Okay. So you observe. Okay. You list down all the inputs. Then you can observe which input. You trigger that. You see there's a here the input energized or not.
Yeah, but how about if let's say this is 4 sensor? 3 sensor is on already the cable.
No.
I mean the cable is on already.
Okay.
So how we define that cable is for
From which one?
Yes,
That's why I say like we measure the voltage. Like.
voltage. Yeah.
Yes.
Because we don't know, right? One time, one shot, 10 sensor on already.
Mm.
And then you have to change one by one. You don't know which cable is for which the sensor, right? Some of the people they will do the marking, like labeling, the numbering.
yes.
But maybe after 10 years, you don't know. Is
Yeah.
the marking still there or not? You
They
know?
go and mix. They do some changes. Of course, the new changes don't have. They don't update the cable.
Yeah, the termination they also like additional they just plug it.
Yes.
Then you also consider when this cable for
Yeah. So the best thing is, let's say 3 sensors. It's already a problem, right? So what you do? Okay, you energize one sensor here, trigger, check the sensors, voltage they have or not.
Okay.
Don't have, then change the cable.
If they say the
All
three
three
also
have,
don't have,
then you need to trace where is it any break or not. That's the only choice.
I think the last thing is tracing the cable.
Yeah.
yeah, correct. That's why
That's the last thing lah, because you can see what, because if let's say is the problem with the tagging, let's say they do wrong tagging, then from here you trigger, you can see
Which one is-
measure the voltage and already. But if let's say all the 3, let's say you trigger all the 3 at the same time, you measure all the 3 don't have the value, means it's all the 3 already got what? Got torn, the cable got torn already. So need to trace lah, where is it torn.
Check on my one.
This time I did one also, one machine.
This one.
One problem, one sensor got problem. Machine cannot run. So they have a cylinder like this. So this cylinder must go up, front and back. And there's another cylinder like this. This cylinder must go like this.
Okay.
So if this cylinder must go like this cylinder must be at the back position. So how the PLC know this cylinder at the back position? At the back of the cylinder you have a sensor. This sensor must be on lah.
Yeah.
So now this one cannot go in. Okay. So they call me. I go and troubleshoot. I see in the machine. Okay. They have what they call they have interlock lah. Okay. They have an interlock. Then I trigger. I see the interlock because they don't have wiring like that now. So what I do? I just take 124 volt from the power supply. I just touch the input lah. Because the input of course from the field. But here I can manually trigger one. Then manually trigger. I ask him to move, can move it. So now I know this is the sensor. Don't have wiring like that. What I do? I trace all the way. Then there's a 2 cable. This is the cylinder line. 2 cable coming like this. Okay. And from here also I don't know which cable because one go in, they have insulation. So I don't know which one. So one is at the front and one at the back. Then I just adjust the sensor lah. Just see one work. Once I adjust, I can work already. So it's moved little bit. Because of just moved little bit, cannot use for one. I think 2 days. He wait for me because he called me that time I was in another place, can do training. So I said to wait. I can do no problem actually the machine.
Just a
All
sensor.
good. They clean up the machine. They go and clean up the machine. When they clean with the clothes everything right, they will move to it.
Only for one sensor.
One sensor just move a little bit. I think maybe move 1 to 2 mm only.
Then last time I got one experience also like this. Get two single phase convert to the 24 BBC at the board, right? Last time I use a multimeter to check. I don't know, maybe I touch on the board or something. Suddenly the board is like moving. Boom. I said, oh.
Oh, what?
I also don't know. But I close out. After 1 hour, I only can use the new.
Normally this one very not very.
That's why I just told you, I thought it's a burn already,
You touch where? You touch here and
I touch here. Then
another one?
The another one also, I need to check the voltage. Okay, I need to check whether got the supply or not.
24.
Yeah. Then maybe I touch something I don't know. Then suddenly boom. Then all the panels shut down and then mine up.
Maybe you touch positive and then this one also touch the positive.
Yes, correct.
So what happened? Normally this one when you mistouch or misconnect, you just hear the sound. But it won't normally it won't burn.
I thought it burned, like boom. I said, oh my god.
But that one, is it still working or what?
Okay, still okay. Then I call Sunday and say, oh, this one I have to order maybe 1 or 2 days. I said, oh my god, flushing can run for 1 2 days, the guy will be arguing.
Yeah. But this one is not
Then
actually not recommend. If you ask me, I don't recommend this for our control panels. It's not good also WinCC brand, but you can use for some other brands, which is more high resistance. Even you misconnect the live also it won't burn.
They automatically cut off.
Cut off, yes. They have some system to automatically cut.
Yeah.
Because they have the coil or the capacitor or okay.
Yeah.
Okay, now this one we connected already, right?
Sorry, sir. Just confirm that connection here. The brown and the 24 volts here is for supply.
Yes.
Brown on the other side is for 2M.
Yes.
AVO
Is 0.
is 0.
Yes.
And AVI.
No need. AVI no need.
AVI no need.
AVI no need.
Only AVO.
AVO because that the signal injector it can can give you 0 volt, 0 to 10 volt and 4 to 20, 0 to 20 milliamp. But my PLC only can bring 0 to 10 volt. So that's why I connect the voltage. Yes, if let's say my PLC can bring milliamp, then I can connect the ground and the AIO. It's a milli current, right? It's a milliamp output.
Oh, but normally this one is like 24. This is 24. Yes.
No, what are you talking about?
No, I mean, like for example, right, sometimes some of the sensor supply is 2 is a single phase.
Sensor.
Some, like for the solenoid valve,
But solenoid valve is the output.
it's output, right? Yeah, because output update. Either 24 BBC or 220. There's a 2 type.
Output or input? Input, you ask me,
Input.
Common is 0 or 24. Okay, like just now, that day when we do wiring, it will run.
Oh.
NPL. Common, where not 230 or it's not common, but you have a module for that.
Yeah. Okay, I understand. That means, like for example, we use the 24 volt and 0 volt as output. Either one.
As an output.
As output.
Okay.
Either 24 or 0. But the sensor is 220. Not sensor, solenoid. It's a 220. We add the delay.
Yes,
Or
correct.
220.
Correct.
Then correct. Either 24 or 0. Out is 220.
No, we were talking about the relay, right?
Yeah.
So relay means So relay will have two components.
Mm.
One is the coil, one is the contact.
Yeah.
At the coil, you connect the PLC output.
Yeah.
Let's say 24 and 0.
Yeah.
At the contact, you connect the 230. Yes.
They mean when energized.
Energize, then the
The
contact
230 will go
230 go to the your device. Huh?
Okay. They mean additional relay.
Yeah, of course.
Got any PLC have this kind of like outgoing is a
That's what we're talking about just now, the relay output PLC.
they want oh
It's a relay output PLC one.
oh yeah that's what I
Can
said.
connect 230, right?
Yeah they mean what you give me the code the output is it.
Yes.
Okay.
So that is a relay PLC. So I can use that.
The next maximum is like two
But maximum 230, maximum can go up to 250 volt. But not the voltage is the important. The important is the load it carries. So maximum like for 1 point can be like 2 amp, 1.5 amp. That will. So sometimes your device, the load is overload will higher, right? Then it can damage your output.
okay.
So that's why they use the external relay.
One basically like lighting oh it's a 230 or 220 right the supply
220 230.
yeah same live and live monitor right we install the PLC the PLC can like this relay type lah
Relay type.
yeah relay type direct I mean the one live connect to the lighting one the neutral going to the PLC
No. Normally they give you the neutral direct go there.
neutral I go then live go
Live through the PLC.
PLC go to live
Same like our switch also same thing. From the DB, neutral direct go.
yeah
The live will go to the switch. From the switch only go here.
that means the we on the PLC we on the power PLC calculate the timer
It's depend lah.
okay
Yes.
lah then on then only on
Yes. Okay, good.
now I understand this.
Okay. What do? You go to go online, monitor. Go online, monitor. No. Monitor. Where you go monitor? Go to main. Yes. Monitor.
Which one?
Isn't the spec?
Oh.
That is called monitor. Okay. Think your PLC is it power on already? Check the cable. I think the cable is loose, the Ethernet cable. Start search again.
Go online
Choose the PLC and go online. Because just now you off right, power off right, you go offline. Okay, go to watch table. Where is the watch table? Watch and force table. Watch and force table. Add new watch table. Okay, you key in here. What is the address? IAI address. IW64. enter. Okay, click here. Choose to decimal. Then monitor. Yes. Okay. Now you increase, decrease. Can increase?
No, until maximum
Right. Then your connection is wrong. Wait. Choose medium. So voltage.
Oh.
Yours got error.
Stop.
Okay, no. See what error, how to solve.
Okay.
Okay, yours got error. Go up. Okay. Go to online and diagnostic. Go to diagnostic buffer. High limit exit. Okay. What high limit exit? This one close. So high limit exit on the AI1, right? Measured value is okay. Means it's more than 10 volt.
Okay.
Okay, more than 10 volts. Okay, why? Where is my multimeter?
More than 10 volt. Yeah, more than 10 volt, 24 volt.
So measure. You connect 24 volt.
Oh, okay.
So why?
Why?
Power off.
Power off.
So why wrong?
You are linked to 24.
The M is going where?
0.
This one, right?
Yeah.
This or this,
Yeah.
right?
Yeah.
The 2M going where?
Input. No, second. Yeah. This is 24V.
This one move here. No, it's correct, but it's not connected to the AVO. Can you see? It's in milliamps.
Oh.
All this one is okay. This one is ground. This one is 24. All okay. This one move to here.
That means the
Is using, I think,
AI 0. They mean AI 0 change to AV 0.
AV0 is in current.
AV 0 is voltage.
AV0 is voltage.
It goes smaller bit.
Yeah.
Then AI 0
It's a milliamp.
milliamp.
0 to 20 milliamp.
Oh.
So that one can use voltage or milliamp also.
Oh. They mean that AI plus is the plus. AI O is 0.
Yes.
Oh. So that means if let's say we use a 10 voltage, cannot connect to the 24V, have to connect to AI plus.
What is that?
If let's say we use a 10 volts, right, it cannot connect 24V.
This 24 and this one
This
is
is a power supply.
power supply.
Okay. Oh yeah. This is a 0. Why this?
This one forget about this.
Okay. So that means this
This one can be
voltage.
this and this is a voltage, ground and I is the current.
Current. Yes. A and I is current.
Ground and I is the current.
Current.
Ground and V is the voltage.
Okay.
This one can give both like change. This one you can buy online also. It's 80 limit plus. So you see, got error, what we do? That's how we do. Go and check in the diagnostic. But then tomorrow also we will. Today is 4th day, right?
Yeah.
So tomorrow also we will learn on that lah. Okay. Now power.
Can't.
Okay, go on. Okay. Monitor.
Monitor.
Click here. Monitor. Okay, what's the value? Increase. So you should get this number, right? Of course lah, sometimes you won't get accurate. Plus minus lah, 10 or 20 plus minus.
Okay.
Because this PLC all okay. The other one is a very old one. That one is a plus minus hundreds. Because many times you connect, disconnect, connect, disconnect, connect, disconnect. Okay. So got the value right? So now I get what number? Let's assume the injector I give you is a 0 to 100 degrees Celsius.
Okay.
Means 10 volt means 100 degree lah. 5 volt means 50 degree. Okay. But in my PLC, what number I get? 27,000. So how to show? I cannot show the 27,000 in the HMI. So what I need to do? Convert. Right? So if I want to convert 27,000 to temperature 100 degree, I need to plot this graph. Correct? So based on this graph, we do the scaling. Okay, that's why I put this now, like this. I didn't put AI. I easily can put here AI, AI minimum, AI maximum. Temperature, temperature minimum, temperature maximum. That's how we need to do. But this is, I mean, for common, for all. Okay. Okay. What we do, we go offline. Okay. Add new block. Put FC. Okay. Why? I want to use as a subroutine. Means I want to do this scaling in another routine. I don't want to disturb OB. Okay. Okay. So you put scale, analog scaling. Okay, ladder click okay. 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 So for this FC, I don't want to use the internal. I will use later for one part only. I will use. Okay. Now what you do? I want to use as a subroutine. Okay, go to conversion operation. No, under instruction. Go to conversion operation. Okay, can you see norm X, scale X? Okay, you take like this. You put one norm X, one scale X. Put beside. Okay, norm X you put in front. In front. Norm X in front. Not necessary to change, but that is easy to understand. Because the idea is normalize the value first, then scale it. Okay. Okay. So what? Okay. Now I want to use for what? My analog for this and this one. This one, right? Okay. So here this value must be what? X-axis. Correct. Okay, your x-axis currently is what? AI.
Yes.
Your AI is an integer, right? Okay, choose integer. Okay, then this one must be real. There's no option, real or long real. Okay, then this one real, choose real. Then no, last one is your y-axis, right? Correct. Output. So it depends on you whether the temperature you want 0 to 100 degree or 0 to 100.0 degree. The temperature you want normal integer number or decimal point is up to you.
You guys say decimal?
Choose real.
Oh, decimal choose real. No, that decimal.
Integer. Okay, choose real lah. Okay. Now, so here is what? X-axis. So your x-axis is what? What is the address?
IW64.
Yes, put that IW64. No, value, put the value first.
Value.
Second one, IW64.
IW64.
Okay, right click, rename, you put AI channel 0. AI CH0. Okay. What your X minimum? 0. Okay. What is the Y X maximum?
2764.
Yes, you put the value. Okay. What is okay? So is here you can use the output lah. Okay. So means I do this calculation. I need to stop into a memory. So I need a memory here. Okay. I have two options. I can use memory or this is the FC, right? Correct. I can use the internal tagging also here. Okay. You click here.
Yeah.
No.
Oh.
No. So you see, okay. You try to understand this. Here I can put memory means, okay, it's a real means MD lah. I can use MD or I can use the internal tags. Internal tag is because from here to here only I want to move one. Correct? I can use the temporary. Like I said just now, temporary within the line you can move data. Okay? So it's up to you. So never mind, try the temporary. So in the temporary, what you do, you put a name, norm X. 1. Okay, and just start it. So what is the data type?
Real.
Yes, real. Just type R lah. Type R. Okay. Now you can put the norm X here. Means I'm using the internal tagging lah. Okay, can? So it's we have options. You can use like this also can, or you want to put MD also can. You have some option. Then the norm, same norm X is your value. Right. Okay. Same norm X is here. So what is your Y minimum, Y maximum?
0 to 10.
No.
100.
According to this lah. Use this. That is the voltage. We assume that is our temperature sensor. 0 to 100. That's what. No. See here.
Oh, no, X.
Yes.
Oh, okay.
Then, okay, you see how it works. Okay, you see, you key in the minimum maximum value. Okay, once I get the value at IW64, you do some calculation, put the value here. Okay, then later in the scale, I take this value, I use this data, calculate, and I put the value inside the output. Now, output is your temperature. For this one, I have an address. Correct? For this one, I have an address or not? Don't have. So I need to create my own. So if I want to create my own, what address I must use? No. What address? What I mean is it I, Q, or M?
IW66.
You see, again I tell you, AI, I have an address. IW64. Want to convert to temperature. Temperature don't have the address. So I must give a own address. What address I can use? Is See the IW,
QW.
no sorry, it's a real right. So ID, QD or MD.
This one is real.
I want to store
And
M because I cannot use I is a physical input. See the I 0.0 or IW. Q also cannot use. Q is a physical output. Because I want to store somewhere, I need a memory. So MD. So any M we used before? No, right? Not yet. MD is it. Or you want to start straight away start with MD 100 also okay. MD 200 also okay. MD 4000 also okay. Okay, it's up to you lah. So what I rename? What is this?
actuation.
Yes. Yes or no? Change. Okay. Now you understand this?
Have to more practice.
Of course, more practice. The thing I want you to understand the concept first. Practice, of course, later we can practice. But I want the concept. Why we do scaling? Why we are using this Normax scale? Why cannot use others?
But sometimes we already forget what we don't know how to key like the value. Forget what's the
Which
value.
one?
Like for example the
The
value.
0 27, no right?
Minimum maximum is okay because we can check from the work.
Yeah, minimum
force.
maximum from the graph we know already.
Yeah. Then
This value,
yeah, we forget.
no, I already put here. Right?
Okay.
X-axis. What is your x-axis?
Analog.
Is what is the output here? Your y-axis. That's why I write in this way. Normally some trainings I don't write this way. I just normally I this one sometimes I don't even write. I straight away show like this. But when I do training, I know they do mistake. So that's why for you straight away I show you here. This is always the x-axis. This is always the y-axis. No matter you are doing scaling from analog input or output. So x-axis, y-axis. From this output, I put it here. Okay? Now, this is a new FC, right? So what you have to do, go to main. Go all the way down. Okay, you call the FC2. It's in the network 3. Okay, can you see this FC are different, right? Why? Because this FC is a code block FC, correct? Inside there we do coding. Here is a subroutine. Means inside there I straight away do the program. Do the program means I straight away use the IW64, all that. I didn't use the internal input output. So that is what called subroutine. If I use the internal input output in out, we call it as a code block. Don't get it. No, very simple. You double click here. Double click here. Do I use any memory?
No.
Okay, what? Okay. Any global text? Do I use any global text? Any PLC text? No. I use the input output, right?
Yeah.
This is called code block. Okay. Go back. Go to main. You open this. Okay. Here, can you see? I use what? The global tag. And I use only the temporary. I didn't use the this one. So this is called subroutine. Means here I do just straight away do the program. I didn't use the input output. Okay, that is different between subroutine and code block. Code block means I just key the input output. I use everything from here to create my own coding where I can multiple times use.
Okay.
Can I use the FC2 multiple times? Like go to main. Go to main. Can I use the FC2 multiple times? Cannot. No point of using.
Yeah.
Right?
Not repeating.
Not like repeating. If I multiple times I use, where I key in data? In input. because it's not like this, right? Means it's only one time, correct?
Mm-hmm.
So I do the program. It's the additional routine, just arrangement program. That is called subroutine.
Okay.
This one here, inside I do some program where I can use multiple time. That is called code block. So any program I can use multiple time, that's called code block. Any program just like this only. If I use multiple time, where I want to key in, cannot, right?
It's only for one skill.
Yes, one skill. No. Inside there I can do multiple skill, no problem.
Yeah.
Just a one block.
One block.
Yes.
Yeah.
Inside there is up to me
You
lah.
no point you put a lot there.
Yes,
No,
you cannot
all
call this block multiple time.
All is the same.
It's the same thing, so we'll have a conflict. Program conflict. Okay, download test. Okay, go to the analog scaling FC. Open that FC. Close the top one and the bottom one. Bottom one, so you just close it. Monitor. Okay, increase.
Oh, they mean the MD0 you can put at the main block there.
Later want to use the MD0 anywhere can use lah. Of course.
Right, for the MD0 at the HMI.
Yeah. That one later we do. Now I want you to understand the conversion. Okay?
But you see, I still mind jumping like now.
Because why? Yours is jumping by your input.
But here's fixed.
No, it always fluctuate.
So how?
Because that one is showing what? 10.0 something. At the back, we don't know. So this can be 0. Now what's the value? 10 point?
Now it's an 8.7.
8.7. So we don't know. We leave it here. It's a 9.0, right? After 0, we don't know here. The other number is fluctuating or not.
Okay.
So it's always fluctuating a bit.
So that means here, just now we change, we can change to the INT, right?
Yes. Then you will get 89.
89, easy to see with 9 figures.
Yes, can also. Okay. So why we do scaling? Later we see lah why we do scaling. Okay. First thing is why we do scaling? Why we convert? Because later the MD0 I can show in the HMI. Right? Because I cannot show the IW64 in the HMI. Nobody will understand. So MD0 I show in the HMI so I can know what is the temperature. Then I can use for comparison. Compare. So means okay when the temperature reach 50 degree, I cut off my motor. When temperature below 50, I on back the motor. Something like that. So only these two places only I do use the analog. That is the common thing lah. So analog, when I get this value, always scale to this number first. This number, this range is depend on your instrument. Just now in the slide we see the pressure 0 to 250 millibar. So 0 to 250 millibar. So your this scaling will be 0 to 250. So here will be in millibar. Okay. Good.
Yeah, like just now you say like you compare, then later we do
Of course. do comparison. Okay?
I mean there is a two set. I mean if let's say there is a two sensor, you need to create two FC.
No. In one FC, like this, another one for another sensor.
Oh.
This one for IW64.
Yeah.
I can do same thing below for IW66. So IW66 convert to the MD4 temperature 2.
There's a temperature MD0 and MD4.
Depend lah which memory is available.
Okay.
Can? Okay. We go for a break. You say first, yes.
How about this one is a linear graph? Let's say how about
Analog always is a linear graph.
always?
Always. But we don't go for how the analog works. Last time we learned, there's one learn digital is like this, right? Analog is this one, right? Right? So you don't go there. Okay, that is the how the analog works, everything. That is different lah. That is electrical. Okay. This one is always linear. If not linear scale, how? So I cannot use the normax scale itself. The normax scale is for linear scale. So if no, then I need to find out the formula because there's no nothing inside the PLC. There's no like this scale. So I need to find out let's say like in the because I never come across this is my own creation lah. Okay, let's say the graph this looks like this. Go then curve like this. So normally if like these graphs will have a formula, right? Their own formula. But for this formula is y equal to mx plus c. If these graphs will have their own formula, y equal to x square or something, correct? So we use that formula. That formula we do our own calculation because we can use. Now this one is for represent this. So let's say for the graph you have like yesterday we do the calculation, right? So we do the calculation. Okay, good. Okay, you save first. Go makan first. Because I need to go buy food. Didn't bring today.
Okay, we can have a lot of analog. Maybe we have 10 analog. That means our PLC need to have 10 analog input.
Yes.
I mean for the sensor input.
Need to add card lah.
Card lah.
Like this.
It's a split like this one is only can add two slot right? One maybe like here got to add the analog card for 10. If let's say they have
They have don't have. They have 4 and 8.
8 lah.
Yes.
8 lah. Then
Yes.
10 analog.
Yes.
We use already. No?
Yes.
So inside the analog can be the FC. Inside one FC.
Yes.
Can.
Can
But
be.
only the memory different.
Yeah, of course. You want to use one FC for all the analogs, norm X scale X, or for one scale you want to use one FC. It's all up to you.
A better one file.
Of course lah, which one is suitable, right?
Yeah.
So I say the arrangement of FC, FB all is depend on the programmer. The main thing is you need to understand how the FC work. FC subroutine, okay, how it works. FC code block, how it works. Function block, code block, how it works. You need to understand that. Whatever program I do is just an example. It's not okay. Motor means okay, must use function block. Scaling means I must use FC. No. Whatever program I just do is all example. So I want you to understand how the FC works. That's all. Not what is the program inside the FC is not a problem here. Not a matter here.
example, like for example, the motor, right? There's a motor A and motor B, and motor C, lah. Okay. For each FC, like A to B, FC, when press start button A, they will run, press start button B, they will run B, press start button C, they will run C. Okay.
Okay.
But I need the interlock, like you only can press start A, one, and only can start B. Number two. Then
Okay.
number two, start you only can press number three. You cannot say like, oh, I
Straight
press
away.
I cannot. That means
That's the logic.
yeah. So inside the network here, need like link or something, link or
Not okay. From your this one, from that itself, you already have the answer already. Okay. Thing is, when I click here, so I have three lah. I can run A, B, C.
Yep.
When I click here, I can run A. When I click B, I can run B. When I click C, I run C. Three input, three output. Right.
Yep.
But the B and C always depend on the A. Means the B lah. If the B want to run, the A must run first. Is it in run condition or run finish? Is it or run condition? Run condition must be in running mode.
Yeah.
Then only can press B.
Yeah.
It's already there, what? The interlock.
It means in the network, you just create a memory.
No memory, no. When I start,
Yeah.
A is run.
Yeah.
When I want to start B,
Mm.
what is the condition?
A have to start.
A have to run.
Yeah.
Put the A as a condition, run the B.
Okay.
I think it's like the interlock.
Yes.
Oh.
Got it?
Okay.
You remember that yesterday, when I start valve A on,
Yeah.
I use the valve A and low level, then only the timer run.
Okay.
So from the question from the sequence you tell, that itself already have all the
We
data.
can create in the inside the FC there.
Yeah. That's the logic lah. When you practice.
If let's say like if okay, now all the three motor run already, right? When motor A run, B only can run. When A, B run, C only can run.
Yes, that's the interlock.
Yeah, interlock. Yeah.
Okay.
But when you press stop, right?
Okay.
C only stop if you press C.
Okay.
If you press, if like say if all the motor is running,
Yeah.
if you press B, B and C will stop, but A is still running.
Okay.
If you press A, all will stop.
Okay.
Same also.
Yeah. From the statement you give, the logic is there already. Correct. When you press C, only C stop.
Yeah.
So, where is the C running? I stop there. Correct. When you press the B, B and C stop. So stop button, put at the B and the C. When you press A,
Okay, maybe additional button for the stop.
I don't know whether you want to use additional button
Maybe-
or you use the same
I
button.
mean,
it's up.
I mean like we don't fix two input at the FC. We
Only
can
one input.
Huh?
Only one input, is it?
We can put three input also.
No, you can put many.
Multi also, right? They mean okay.
That's right. This one you cannot imagine, you know.
Yeah.
This one is, okay, you have this idea, what you do, you do a flowchart. From the flowchart, you do the program and test.
Okay, maybe like I do the FC. I fix three input there.
Yes.
Okay. But for the motor A, I only key in the 1. In second FC, got the 3, right? But the input I
I don't need. Because what you are telling is, in one FC can do what?
yeah. Inside the FC, I create already.
But the
Block.
block,
Yeah.
one FC can enough already.
One FC enough already.
Yeah. Because all the ABC is there already, right?
So inside the FC.
Not inside FC. I know you are talking about the code block, right?
Yeah.
So when you call the code block, of course A, B, C will come up. You must FC, right? You must key in all the data.
Yeah.
No need to call 3 times.
Give an example. Sketch for me, and then I see. Then you sketch, then I know already.
Oh, very easy, very straight. Can I erase this?
Wait.
Okay, so you have how many button? 6 button.
6 one start stop.
Okay, then 3 output.
Yeah, correct.
Okay, so all push button lah. So I put SA lah.
SA.
SA is for the start A lah. Okay. Then motor A, right?
Yeah.
Motor A, then
Right.
I don't put the stop first lah.
Yeah.
Okay. So when I press motor A on.
Yeah.
Then for the SB is motor A must be on first, right?
Yeah.
Motor A on. Then I press the SB.
Motor B on.
Motor B on. I right shift.
Front.
Wait.
After.
After or before?
After.
No. Wait. I need to read.
Okay.
Okay, because MB is right.
Yeah.
Okay. Then when you press C
Is
A and B must be on both, right?
that means the MB on.
MB on.
MB on.
MB on lah. So
Yeah.
MB on. SC on. And motor C on.
Yeah.
Motor C.
Right.
That's it. Okay.
Yeah.
Okay. Now I press stop C. Motor C off.
Yeah.
So
Button. Yeah.
stop C.
Yeah.
Now I stop B. Motor B and also C off.
Then we stop B on you.
No.
Yeah.
Stop B and C off.
Yes.
Stop B.
B. This one no need already, ma.
No. Need.
MB off already, oh. Oh, yeah.
Because you put the push button back.
Yeah.
So latching. So SEB. Okay, now when I press stop the MA,
Oh,
A,
stop.
all will stop.
Yes.
Okay,
Yep.
this is the your program.
Yep.
So you want to do a code block
Yep.
in the FC.
Yes.
So all this in, right?
Yeah.
All this out, okay. So S A stop A, start B, stop B, start C, stop C, right?
Yeah.
Motor A, motor B, motor C.
Yeah.
I just connect all the data. Why I want to create 3 times?
Oh. Okay.
Fair.
I know. I get your point.
If you want to do 3 FC, but with the same condition like this, can also.
Okay.
You take picture, I will do that.
Okay.
Means you wanted to do 3 FC, right?
Yeah.
Different FC. But
This one the FC the SA we key the input, we put the input there.
Yeah.
Right.
Yeah.
This is our own
our
internal
tech. Yes.
we write ourselves like
Yes,
that.
yes.
Got the aspect there.
Okay.
And there is an input we key like the I00102. Okay.
Maybe you take another picture.
Or means like if let's say we have one system, we can do one FC already. Oh.
Okay. Now I show you the same one, 3 FC.
Okay.
But we can't do FC. Must use a function block.
Why?
I will tell you why. Okay. What your idea is something like this, right?
Yeah.
Okay. Now, so now I need to create. I must use this one because this is the one have all the interlock.
Yeah.
Okay, I must use this one.
Yeah.
This is just the motor. Okay.
Okay.
Then this interlock must be the previous motor. Okay, the previous motor.
Yeah.
Okay. So I just put PM. Okay. And this one just the start lah. Okay. Start. This one have a 3 different. Correct. So I use the same thing. Start A, start B, start C. Now this one I must use function block. Why? So this is the FB1. Okay. So what I have? The previous motor, the start, the STC, STB, STA. Okay. Or I put interlock 1, interlock 2, interlock 3. Also can be some of you. Okay. Now output is only one motor, right?
Yep.
Function block 1. This is DB1. This is DB2. The previous motor, the start, C, STB, STA. Okay. No, I don't want to do this. I want to put later I want to use the names. Just put IL1, IL2, IL3. Okay, interlock 1 to 3. Okay. So here IL1, IL2, IL3. Huh? So IL1, IL2, IL3 is the motor. Next, this one FB1, BB3, right? So PM start IL1. It's a stop, right? So
We'll stop.
stop, right? So no need IL. It's just a stop one, lah, kan? I can put stop one. Why I put that? Stop 1, stop 2, stop 3. Stop 1, stop 2, stop 3, stop 1, stop 2, stop 3. Motor. Okay?
Yeah.
Good. Now, this DB is for motor A, motor B, C, yeah?
Yep.
Okay. Now, for motor A, I have a previous motor, no? Don't have. Okay? So, what I do, because I need to start first, initial lah, right? So, what I do, here I put a memory that is always on memory. Okay? Always on memory, because then only can on. This one is the start A, is the SA, right? Then for this only one interlock only, right? Right? Only one interlock. So ST1 lah, right? So the stop A. Enough motor A. But later you try and say, yeah, okay. For this one, I have a previous motor, correct? Who is the previous motor?
MA.
Motor. MA start B. This for this one I have two interlock, correct? STA, STB. Motor B. For this one, who is the previous? Motor B, right? Then start C. This one is the STA, STB, ST, C, right?
Yeah.
Then motor C. Okay? Okay. Why I tell you must use function block? Because for the first block, I don't have these two data. Correct? No interlock. So I delete them. FC cannot do that. Have to put. So still you can use it. The FC also can use. but you can leave it empty lah from some unused memory. Here also do not use it.
Yeah, that's right. Because why? I'm thinking right now, right? Because we have the 3 motor, but in the future we will. So at least I create 5 or 6 motor there first, interlock everything. At least I can put. Then in the future at 3 I just another new block. That's it.
Can also.
Then I just key in the interlocking mark, right? For the SD4, SD5, SD6.
Yes.
Yeah.
Can.
Yeah, this is what I want
This
to
is
do.
what we want here, right?
Yeah, I want to learn this. More simple.
Yes, yes. Can. You just need to try it out lah.
Yeah.
When you have time, just try it out, try to understand how it works. But this one is based on the logic lah. It's the main thing is you need to create a common logic for all the 3. Because if you put common logic is what just start stop enough, right? If sometimes what you think hey, one interlock enough already. No. First motor, one interlock enough, but the third motor must have 3 interlock, 3 stops. So you need to create for all means, you need to create all the interlocks lah. Then the first motor don't want only use 1 interlock, okay, 1. Second motor 2 interlocks. Third motor want to use 3 lock.
That's why in the period I checked from the Siemens, they created a lot of the block. Then I don't compute what is the reason.
Okay, good.
Okay.
Let's go for lunch. I need to go buy lunch.
So that means if this kind of interlock, you recommend to use is a function block.
Yes, yes.
So that means we need to create our block first.
The logic inside the logic.
The logic first for like 10 motor or 20 motor we can create first.
Yes.
Until the last one. This is what we need. Can we say like
No, okay. Once you get the idea ready, no need to create all that lah. You straight away create this one because once you click for 1 or 2 motor, you get the idea ready. Then you don't need to like just now I create 3, then only I take this one, right? You know what you're doing. No need to create all the time. No.
2 enough already. Then we know
From
already.
the 2, you will know already. Okay, in front must have the previous motor interlock.
Yeah.
Then after the latch, I need all the
all the cutoff.
so how many motor? Yes, finish.
One question.
Yes.
Let's say the always on memory, we put at the function. Can.
At the function when inside the FC, is it?
Inside FC.
Cannot. Oh, because for PM, right?
No. Okay. Like for this one PM. Okay, this one PM. Where we need to put? I mean,
The
This
always
PM.
on.
It's here.
They mean here become the normally closed.
Here, no, here normally open only.
Okay.
There's no this one. Okay, you see, why I put this one? Because for this one, I have a previous motor.
Yes.
For this one, no previous motor.
Yeah.
So if I just press that only, it cannot run the motor.
Yeah.
So I need something in front.
Yeah.
Okay. So I don't have anything. So I just put always on a signal lah. I click on always on a signal. Later I show you how to create the always on signal.
Can create the main block there also can.
Yeah.
I mean at the first network.
Yeah. First network we can click on always
Online,
on. Or in the PLC already have the function. We just need to enable the function. Once we enable, we know already. We can use that.
Okay.
Okay.
Okay. Yes.
Is there anywhere, any shop nearby I can buy Siemens? Nearby here, no.
Nearby, no. Only the MDS. On the signal, is it? buy food and come.
Yeah.
It's like this little activity is not enough. We need to do like some more activities.
Yeah, do this one.
Okay. Continue. We continue with the compare function. We learn FC, scaling into compare. Compare is after we do scaling, right? We have the temperature value, right? Okay. We can do some comparison. Okay, what I want to do, maybe just go to main because we already use all the input output, right? Go up. Maybe this one we delete lah. This one because I want to use the start, stop, and motor. Okay, so this FB just delete. No, this FB only one FB. So this program will have one FB, one FC. Okay, so you make it bigger here. Go up. Okay, which FB only one dB, right? The other dB all can delete. This one can delete. This two can delete. Delete. So I think additional dB, yeah. Delete. Yes. Okay. Wait. Don't delete this one. This one is this one. Okay. So in this program, one FB go down, one FC, okay, go down. Then another FC that is the for the scaling. Okay. Now I want to create another FC. Do the compare program. Okay. So remember all these are I can do it OB1 also can. I'm just arranging my program. That's all. Okay. So you create another block. FC. Okay. We name it a compare. Okay, go to main, call the compare block in network 4. Go to network 4, call the compare block there. Okay, alright. Now open the compare block. Okay, here I want to do the compare program. So just now we already F the motor 2, right? We already deleted. So start, stop, motor 2 we F, right? Okay. Because why I delete? If I already use in any of the program, I cannot use here. We have a conflict. So don't think this is another program. Because sometimes the participant think FC means okay, another program. So I can use back the same address. Cannot. Actually, it is all in the same program. I just arrange only. Okay. What do? You put normally open start. Put the start to. Start to right here. Okay. So what I want to do very simple lah. So when I start, do a normal program. Start stop normal. When I start, motor on, stop, no need first. motor and latchet. Okay, stop. Actually, no need. Okay. I want to use comparison, comparator operation. Okay, can you see? Equal, not equal, more than equal, less than equal, more than, less than, all that. Okay. So it depends on which one you want to use. Let's say I want to use more than equal. Okay, take the more, maybe network 2 lah. Okay. Take the more than equal. Yep. Thank you. Okay. So you see, a comparison is similar like a normally open. Okay. Same like the normally open. That is, if the top value is more or equal to the bottom value, then I energize this line. That's all. If the condition is not met, then I off them. I cut off the line. Very simple. Okay. But it's a normally open. Okay, means it only can energize or cut off. So what I want to do, I start the motor on. Let's say when the temperature increase, I want to off the motor. Okay. Okay. On top here, you put the temperature. Okay. From where I get the temperature? From the scaling. Correct. Okay. Okay. How much? Let's say 50. Let's put 50. 50. Key in 50. Yes. I said more than 50 degree. Right. Okay. Then, if I want to off the motor, I need to create a memory here. Put a memory. What memory I can use? Here MD0, right? Let's use M10.0. MD4 can. M4.0 can. D cannot because it's a boolean, right? Off. 4 can. 4.0 is okay. Yes. Okay. You rename. You put off motor. Cut off or high temperature. Anything. Okay. Then use this to off the motor. Okay, download and test and see. Okay. You press that. You follow this address. What is this address? Okay. Now the temperature is what? 14, right? Okay. Increase. Increase here. So when you go more than 50, it will cut off. Good. So the analog, right? We do scaling, right? Mostly only for the two things. After scale, I show in the HMI. After scale, I do the comparison. Correct. Okay, okay, understood. Okay. Okay, just test pasal. Just to be honest.
Actually, one of our machines is using something like this.
Yeah. 有差别吗？照片给我看一下。对，一个高一个低。哦。然后看一下，看一下，看一下，没有看一下，不要看一下。前面看过去可以看到一个高一个低，它的前面某地方，然后另外一个轮子那边哦，啊，对，再看一下，这个是2力刀的东西，我最重要是那个2力刀的东西。第二个就是一个轮子，搭一个轮子条例哦。另外一个啊，就是我之前跟你讲的，那个方盘的方向太高了，方盘的那个上面那个太高了。啊，你从那个上去有600，将现在有600呢，应该是多过600吧。所以就是800咯。你想看一下，现在它的那个能力是在90值，打一个800就跟你的差不多一样的。他们那边是矮的比较多，所以讲这样，他会搞对这一点。等他们星期1、星期2搞没弄，可是你要带先了。不要还有还有么？现在是星期6，你现在才update，你觉得下个星期还能上吗？肯定上不到的。不要他突然间讲，不能的，我做别的东西了。我讲那时候真的，先给你知道这个问题先嘛，不要等下，然后过后要傻了，然后他做别的东西了，肯定死了。生活要每个大概几点钟爽？带上是净水、防水就带到了，然后还有带什么不能用啊？不要讲，现在在晒，先讲不能没有晒先。对，没有等下，然后就讲，做这种但是他这边不得看。OK， 那你好啊。你会问那个台风呢？就是那个老板要聊。哦，那个柏林那边，一个我看到是 是圆的，它的是圆的，你的是四方的。现在这个给他们优先，到时候他肯定会考虑的，这个肯定会考虑，我告诉你自己，肯定会，因为我第一可能 Steve 就可以看到的，他肯定会问你怎么这样子的，啊，等回来。其实这样子讲，先讲个优先，然后问问题尽量讲继续就不要。没有讲话，就是讲我们就是讲，没有我们就讲，但是你讲什么要问什么，要问哪一个不好，就不要讲了。等他，对，等他人家问起的时候，我们讲，也对方其实讲，我们觉得应该想要能关于他想讲，怎么给大家个因为我们也是熬得过来了，因为这个不是我们做的。这样子，然后就是到时候看出来。
Sorry. Okay. Can you understand? Compare function. See, the compare, right? What we compare? MD0 is the temperature, right? Okay. 50, then I on M40, okay? This one after I do the scaling, right? If I didn't do the scaling, okay, if I didn't do the scaling, can I do a comparison? If I didn't do the scaling, can I do the comparison? Okay? Okay. Oh, same compare, but I don't use IMD, I use the IW64. Okay? M4.0. But what will be the value? After, right? Okay, so our graph is like this, correct? AI, this is 0.27648 convert to 0 to 100, right? So now we set as 50. Okay, so 50, half of this, what do you get? 13,824, right? So when you put 5 volt, 5 volt is 10 volt is 27,000. So 5 volt is 13,800. So I can put this number. Still can put, right? Right. So this one is an integer. So both are the same thing. So you can, let's say I have a control similar to this. I start motor run when temperature is 50, motor off. Okay. I can do scaling. After scaling, I compare also can. If I don't want to do scaling, I straight away want to compare also can. Okay. But I need to know 50 degree, what is the number? Maybe I do manual calculation, not my own calculation. Okay. Or 75 degree, whatever. So can, no problem. But why they do scaling is make it easier, right? You know why? Because you don't need to do manual calculation. Just key in the value, it can do calculation for you, right? So convert the value into the unit, correct? This is called raw value. It can convert into a unit. So easier. In the future, you see the temperature sensor is not accurate or plus minus 2. So you want to add 2, right? Offset, correct? If you do this program, easier. Okay? Because you go to this program, change 50 to 52. But this one how? Need to count, calculate, right? So calculate how much. So example lah, 14,200, for example. So that is the reason we do for what? The scaling. Very simple. So after scaling, mostly 2 things. One is compare, one is show in the HMI. Okay? Any question? The scaling.
No.
Yes.
And compare the right function. This is compare block.
Okay.
Okay.
You mean this block is it?
This block, yes, correct.
Okay.
So inside this block, right? After we finish up all the program, compare program for like motor A, compare like further, if the more temperature is more than 20, then we have to cut off the
Yes.
motor 1. If like after the 20, I need to on motor 2, so can write another
Yeah,
one.
of course.
Yeah. Then shall we put the compare to the main block or no?
No need.
No need. Because like the what called motor FCFB, right? You need to put at the main block there, right?
Okay, yes, but we already call this block what? The whole block we already call here, correct?
If they say the compare, we didn't put at the main block there, huh? They mean only the block.
Then okay, I know what. I'm
Because we
not
create,
sure. Okay,
we create.
Okay, I know you create this FC,
Yeah,
but we didn't call here.
yes.
Of course, the program inside won't work. That's the first thing we learned that day, right? Because why? When PLC only can scan OB.
Oh,
Inside OB, I have FC2, so can scan the FC2.
okay.
I have other blocks can scan,
Okay.
but FC3 is not there, so it won't run. Even the FC3, you go to main. Let's say I don't want to call here, for example, lah. You delete. You go to the analog scaling. I want to call here also can. Take the FC3, put it here.
Oh.
Because I call FC3 inside FC2, and this FC2 I already call in the main. So somehow go to the main. Like a tree lah, right?
I mean the most important is need to go to main.
Yes.
Okay.
somehow need to connect it to the main.
The main we also can put the password, right?
Yeah. Same thing. Same thing.
So they mean before they upload the program, they need to key the password.
Yes. Upload or download. Okay. Now what you do, whatever you done, you save. You do a simple project, small project.
Okay, then okay.
Yes. So day 4. This one day 4 lesson
Lesson
2. Lesson 1, right?
SMA.
Yeah. So new one day 4 lesson 2. And you click new, add new PLC.
给他看是感觉很 OK，可是感觉到很多时候都放不到位置。他放在方位的，他就是两条的，就是他拍了两条的，你又不能插电影啊，对呀，都出来的是平常不是司法内。继续，他别 UCC 啊，可能分3个人，3个司法这边的，3个人3个司法这样子。
what
明白他就是看你这个司法过关会几点，有几点在那边有哪个就是有不一样。右手边那个不一样。
Let's say we have
市场的话出来在打工上面的一个
start button,
上
stop
面
button, one
然后
compressor. Okay, compressor. So, let's say this compressor give you a pressure value. That is your meter lah. Let's assume that is the pressure value lah. So start button, stop button, one output is the compressor. So when I press that compressor on, so you increase the pressure. When the compressor off, you decrease the pressure. Okay? So the compressor will give you the current pressure. Right? Okay? Then, so this is your input I0.0, I0.1, Q0.0. Okay? Then your current pressure is from the analog input. You need to convert first, do scaling, right? So your pressure is from 0 to, let's say like the 250 millibar. Okay? Okay? Then I have two set points. That is the cut-in pressure and the cut-off. Cut-off pressure. So cut-in pressure, let's say, is less than 200. Cut-off more than equal 220. Okay? So how to do scaling? This is the scaling. That is your AI, which is 0 to 27648. I convert to 0 to 250. Measure in millibar. So very simple. I want to maintain the pressure inside the compressor in between these two. Okay. So means when I press start, compressor on, go until 220, cut off. And cut off, I mean the compressor is off. Then you decrease the pressure. So when it go less than 200, on again. Off, on, off. That is just repeat lah until I press stop. Okay. So the IO is there. Input, output, and here is the your AI. What is the address?
64.
IW 64. Okay. Now the flow chart. Okay, how the flow chart? When I press start, first condition, and also your current pressure. So your CP, current pressure must be less than cut in. Compressor on. Yes, okay. When compressor on, what happens? The pressure will increase, right? So when current pressure more or equal to cut off, compressor off. That's all, finish. So when compressor off, what happens? Pressure will decrease. So when pressure decrease, go. So the current pressure less than cut in on. So just repeat it. So when I press stop, the compressor off. create one FC. Inside the FC, you do this file, this project. Scaling and also scaling and compare the same file can lah. Okay, can.
The tag we also can create in the FC, right?
It's up to you. It's up to you how you want to create the tag.
Or create at the PLC tag first also can.
Yes, this one you need to create first lah.
Yeah.
The rest is up to you how you want. You want to do subroutine, you want to do function block, you want to do FC, code block. I leave it to you. Okay.
I need to choose my screen because it's just continue loading and just.
That is only.
Yes. I think it's 4 by minute.
Increase the pressure. Decrease the pressure.
Decrease number. Solve the error then. Decrease the code. Why?
Troubleshoot.
Yeah, something we need to add. Block it. Okay. Question of the normal X and the scale X, right? Normal X we can declare like the original sensor. The rotation.
The raw value.
The raw value like 0 to 10 and also like 4 to 20. If they say 4 to 20, the minimum is 4. The maximum is 20. And the input value, we just follow we check from this device lah.
Yeah.
See is a 64 or others, based on that lah. Then after that, IW is at the top.
Yes.
Then after that, it will automatically generate the output. The output is storage in the MD,
Yes.
cannot MW. Because I tried MW
From where? Which one?
output.
The norm X output.
Yeah.
Must be because it's only real, but
Yeah. Oh, maybe only real. Then you have to key MD.
only.
Then the scale X all is the real, so also MD.
Yes.
I see. Because scale X there, that means the value is from norm X
Yes.
output.
Yes.
Then the scale X, the minimum what you need.
Yes.
Like you want to start from 10 also can, you want to start from 20 also can. And maximum you can reach until 1,000, 2,000 also
Yes.
can.
Yes. Yeah.
Then after come out, we store another one memory.
Yes. Correct.
This is after conversion.
Yes. That is the value of your sensor lah.
Okay. That means this is a scale. We don't need to do any extra like normally group open, normally close, no need.
No, you need. This one just convert the value only.
Then compare also same. We just put in the compare from the memory unit.
Yes.
Then just come out the output what you want.
Yes. Correct.
If okay. I see.
Yes.
Why?
Sometimes because just now open, you do some changes,
Yes, correct.
download.
Yes.
So it shows that it asks you to do what? Reset the core environment.
Yeah.
So reset
Invalid core environment.
environment. So ask you to reset the core environment. Means
Yeah.
close, open again. Because why? Inside the PLC is already new file,
Yeah.
new project.
Yeah.
Just now one open, right? That's why I asked you to reopen. England I already sent them.
Yeah, if no one else wanted that big, give it to them, don't it? Because it's already no more probably. Yeah, already too close. Customers. Mongolia, guys, if you want to book issue, you book 3 or 4 weeks in advance or so. Yeah, so last time was the same, correct? You know, you book, you don't know what you buy means it's not.
Okay, I check this now.
start from there. After the press stop, right? Then you have to cut off all the if I turn up to 200 bar, right? Then less than that, then all back the compressor. Right. And here is connection as well. So here I put
Maybe you try another type. Another way.
create a block.
That block nothing to do with logic. Logic is different. Block is just we are arranging a program. how it's going. Still cannot.
Still trying.
Just try it one way.
I use a lot of method, like interlock, I mean the P and N. Now I didn't like look really. I use a compressor when on, one I use N to on back, I mean the spark lah. Now I this one thing. Is that after the press stop, the whole thing needs to stop. This is the thing I cannot imagine. I try to force, I can force like all stop, but it will become an upper door issue already.
This one bring it up.
No, I choose a lot.
This one bring it up.
Okay. You want to see my previous one?
No.
This one no, I tried that only.
Not working.
No working.
Actually, compare block no need.
This one.
Can put in one.
Oh,
This is one flow chart, right?
yeah.
So you can put in one flow chart.
Let me put over here.
I mean, okay, this one is okay lah because this is considered what? It's not in my flow, right?
Yeah.
So I can separate it. It's okay.
Yeah.
Okay. But the compare, I go to compare.
This is my fault.
This one, right? No need actually. This one together also can.
Okay.
Or maybe the whole compare program you do it here. So the main OB just call the blocks only.
Yeah.
That's how we must arrange. Because this is not it's not like, okay, scaling is different. Scaling because I want to convert the values.
Yeah.
It's not related to my flow. But this one is related to my flow, right?
Yeah.
So together with my start stop everything.
Maybe I can put in one FC.
Yes, one FC the whole program.
And after that put in the OB there.
OB, yes. So if anything wrong with the scaling, I go to the scaling and check. If anything wrong with my process flow, I go to the FC and check.
Okay.
Actually, this program is very straightforward. You guys are missing one thing. Maybe you didn't see that. That's okay.
Come and see first.
No. You are doing in FC, okay? Go down.
I created one FC for worksheet, another one for scaling.
Okay.
So this is for scaling.
Okay, go down. Okay, scale set. Okay, compressor set off. Set on, set off. Okay. Go to the program. So start stop. Actually, start stop you're doing the interlock. I mean internal variable, right? Then later on in the main OB you put the start stop motor, right? Correct.
Yes.
You go to main. You put this, right? Actually, not necessary. Not necessary. Unless I have 2 or 3 compressors. Then I do like this. If no, this start stop compressor, right, I straight away put inside. No need to use the variables. So because why? Sometimes like this, right, it will be difficult to troubleshoot. Okay, never mind. You go to your program. But never mind, you still go to your program. Okay. Stop.
Stop.
Stop. Right.
Yes.
No, this one.
This one.
Yeah. Up. Can ah? How the, you see, you just see here, you can do already actually. From here you can do already, see. Okay. So let's say I do scaling already lah. Do scaling ah. Once I do scaling, okay, let's say I do less than the current pressure 200, right? Here, cut in. Okay. Then another one is the current pressure 220, is it? Cut off. Okay. Yours is almost there. See. I start. Okay. I start. Then there's another condition, right? Right. So you got two conditions. Then only compressor. So what you put? You put the compressor set on down there, right? It's not down there. It's supposed to be here. The cut in. I start, okay, and cut in. Then only the compressor. According to this correct? Okay. Then you check this. Is it working? Cannot. Push button. Latch it. So you don't know where to latch, whether it's here or here. No problem. Just put it here. Then you test again. So below 200 can start. But the moment it becomes more than 200, this one will off, right? So this one will off. So the latching must be after this, because your program just has something similar like this, right? Good. Okay. So compressor on already lah. So when more than, compressor off. So cut off already high. So cut off. So compressor off already. When I stop, compressor off. So one cycle, okay. So if you want to start, you need to press that again. Okay. Now repeat. Correct?
Yep.
Repeat. Here itself, actually I put repeat. Means the repeat must be before the CP. Right? Means something here. Something on this line. Okay. Have you tried? Keep on press this one on again. You see, I just explain. So let's say this is normally closed, normally right. When temperature, when pressure less than, I press start. Okay. On the compressor. And just then you release your hand. So it will off this, off this. So when it go more than 200, okay, this one will off. When it go then to 220, this one will cut off. So this one will off. This one will off. Right? Okay. Then you go below 200, what happens? This one on back. So you need to press start again. Let's say if the start button giving you a continuous signal, can I on back or not? Can, right? Okay. Means if let's say this one is like continuous signal. So when below 200 can on, above 200 this one will off. So above 220 can cut off. Then below 200 can on back, right? Okay. But this is the start button. I cannot make it on, right? It's a push button, right? But from the push button, I can create something that is always on. Cannot. Now this is the push button, that's why I cannot repeat. But let's say this is the selector switch, can repeat. But mine is a So from the push button, can I create something that is always on? Very easy. That is, when I press start, I use a memory, for example, run, and I latch it.
Okay.
I take this run, I put it here.
Remove the memory.
So what happens now, in front right, it will always on.
Okay.
So I can increase, decrease, increase, decrease, increase, decrease.
Okay.
When I press stop, I stop here. Of course, this one also need to cut off. Correct or not? So I cut off. Yes.
That's right. That's right.
You know where you start, you know. What do you say? You want to repeat means must off something. Use negative pulse.
That's why I use the pulse.
Yes.
The start I use the pulse. They mean everything is something signal give me. At least I don't concern about the start.
Yes.
Thing.
So it's not because of that. Means I know you give pulse when compressor off, right?
Yes.
Actually it's not that. When it's on, if let's say example, I put like this. If the flowchart when compressor off, then compressor on again means I can use the pulse of this one. But I put a condition one. That is compressor off already. But again when it's less than, then I on back.
Yeah, I like bottom there.
Yes.
Got the pulse. Maybe we create.
This is you see, create, test, try to understand the logic. Where can I put the
Maybe we finish out all the logic first.
normal first?
First until
Yes.
finish, then only see how to link.
How it works, where it can continue, what I can put. Okay, now, but yours is wrong. Okay, this one you must put it here. Okay, you try to put. You just drag this, put it here. No, click on the normally open. Drag and put it here. Yes. Okay, now download.
If let's say in the next time, right, we make it easier, we all create like the start stop memory
Yes.
and run. And at least
So you can use that run where it's
which
like an
run?
auto lah.
I like auto lah. Then stop, everything stop.
Yes, can. Okay. Now you press start. You press start and hold. Okay. Now you increase. Okay. Now you know what is the pressure? You know, right? Correct. Difficult, correct. Put everything in the same network. I mean same program. Easier. Okay, I will show you. We arrange these programs. Okay, go offline. I will show you a proper program. Okay, you open this. All these take out. Only the start, stop, compressor take out. Delete. Okay, close. The one cannot. Close. Okay, here you put your actual start, actual stop, actual start PP. Okay, stop PP. Compressor start. Compressor start. Okay. Now go back to the where is the scaling? This one right click, update. Okay. Go to scaling. Go down. Okay. Go to scaling. Open. Okay. You right click network to cut. Go to the compressor logic. Yes. Right click network 1. Network 1. Paste. Okay. So no need to separate this. Put this in one FC. Easy to see. Right? Okay. Now you test. Download and test. Okay, click OK. Okay, close. Close, open again. It asks you to reset the call environment, close and open. No, the compressor. Okay. Monitor. Okay. Now stop.
Stop button.
Okay. Go below 200. Okay. Start. Okay. Go above 220. Okay. Okay, cut down, right? Okay, go below 200. You see here. Okay, can you see? On back. So now you press the start and hold, then you rotate. Okay, go more than 200. Okay, less than, so you see, still on, right? So go less than 200. Okay, on back. So we create this. Okay, go offline. Okay, you create here. You click here. You add this program. Then, so whatever program we do, we see.
Okay.
So we can modify, we can modify. Okay, this is your program, is it?
Yes.
Okay, go down.
So this one is the scaling.
Okay.
So I define 3.
Okay, okay, good. Where is the problem? You know, this is the problem. You cannot output, you cannot 2 times. Here itself is a wrong logic really.
Output can also times.
Correct or not?
Can I say that less than 200 on?
Okay,
Less than
correct.
220 also on.
No. Now what I mean is, here itself, is it your output on now?
Yes.
So you go up. Okay, go to less than 200.
This one one is less than 200. I change to 200.
No, less than, you put less than 200.
Less than 200. So one press start, this one line going.
No, less than 200.
Less than 200. So less than 200.
Can you see automatic on? Stop.
So which one?
Stop. Press stop button.
Okay.
Can you see?
Still on.
So you see
Mm.
that you always follow the rule. The rule is if the output one time I used already, I cannot use multiple time. Okay? According to the logic here also, only one time I on. Correct? or not?
Yes.
I didn't on multiple time. So you need to play like this. How? You go down. That is okay. Less than you want to on something, right?
Yes.
What do? You put a memory here. You put listen to this one. You put a memory here. Then you try to use this memory to on the output. Like this. You wanted to do something like this, right?
Okay.
So try to use memory. Then you try to put interlock there on the first line. So always keep your output only one.
So meaning that this one I change to memory.
Memory.
Then I
Then
move to here.
I don't know. That is, you see what I mean? What I'm correcting you.
Okay.
Can you get it? Right. So output only one place. If anyone want to on this output, must be on this line only. So that one is it's not wrong, you know. It's a wrong logic. Your logic is wrong, so it won't work properly. You'll have a conflict, program conflict. What you want to do, you let me know. I can tell you. What is your plan here? Go down.
Okay.
What is your plan here for these two?
Okay, this one I'm thinking because less than 200 we cut in, we start to run. More than 200 we cut off.
Okay.
So from 200 to 220, this one is on or off.
You tell me.
Okay, less than 200 is on.
Okay.
So supposedly more than 200 still running.
Yes.
So still running. Let's say this one more than 200, example, more than 200, still running. I change this one to memory. So let's say I move less than 200, more than 200. I'm putting here the memory here.
Where is your more than 220? Don't have. Where's 220? Here, right?
Yeah, this is more than.
Already have, right?
Yes.
Then this one only 20. This one and this one is exactly same. Only different is okay. You wanted to put the less than 200 also still on, right?
Yes.
Actually not necessary, but you want to put also can, not an issue. So need to cut off. I mean use a memory here.
Oh, we both using memory.
Must use memory. This one is wrong.
Mm.
I see. I can tell you that this one.
Okay. So here we always on
One output, yes. One coil, one output.
Okay.
So make our life easier, easy to troubleshoot, easy to write program.
Because just now before talking about the memory to start, I'm using this one. So here the current standby here. So planning that once more than more.
You know the idea is, I know your current is standby here,
Yes.
but when the current standby,
Always standby.
yours is always standby, right?
One off then standby.
Yeah. So not like that. It's supposed to standby when I start, right? Okay. And at the start, this one supposed to be go up. It's supposed to be put on top here. Because you see, I start less than, then only I on the compressor. This one must be here. Don't put below here.
Okay.
If you put this one here, this one no need already.
Because that's how I'm putting here without standby, so without standby current. So I'm using it as a standby current.
The problem is you see this is as a current, right? That is the problem. You must see as a logic. So very simple. PLC very simple. When I start, what I do? When stop, what I do?
Okay.
When cut in, what I do? When cut off, what I do? That is the condition.
Okay.
So you need to think that way.
Okay. So let me try it.
Yeah.
Okay.
Because we all have different style, right?
So let's say in practical, I can using the motor off as a standby current. Let's say in the actual
Motor off.
as a standby current. Because that's how we don't know using the memory to hold.
Yeah. But the thing is, if it is can work. There's no rule. Here also, this one also not. It's not a rule. That's one example. There's no rule. If can work, can work. If cannot work, then cannot. Yes. So because it's a logic, right? Different people, different style of logic.
That's right.
Can sure.
One question I just like thinking, right?
Yes.
I'm still like always think for the big project lah, like few part, right? So every okay, one of the people I mean 4 guys, right? Each of the guys they build their FC inside like we do just now. Then the main OB, because for example they have one machine for one button, but we press the main machine have to cut off all. Can we do like in the OB, main OB, all we put, but the stop button at the front for this 3 of the function. That's it. Can I? Then when stop, all will stop already.
That's what I do for UTM also.
Okay.
I put put a few FC, one FC for scaling, one is for so what I put in front in the OB. So I managed to put all the stop in all the places.
Yeah.
So I just put in the main. I put stop, then only the block.
Okay, when stop, all will
Then
cut.
so what happened? When I stop, my PLC will stop scanning the program.
Okay.
So when PLC stops scanning the program, what I do? All will off.
is it possible we can set on the HMI?
Yes. How?
So that means that here
Hmm.
we will have to lead to HMI.
Hmm.
We will put, let's say, split HMI. We can put like a memory word.
So this is what we call is a constant number, like a timer lah. So if you want to put in the HMI, so I need to put a memory there. Yes. So we can put in the HMI.
Mr. Ian, try doing this program, these two. These two. Why after we below 200 on? Okay.
Yes.
Above 200 off already.
Above 200 off already.
Yes. So we try this one. Okay.
Above 200 is off already. Okay,
Yes.
you troubleshoot. Okay, we see why.
It's because of the comment below. This one. That's why you do this program, you still need these two settings.
Motor on, motor off. Okay, you go down. Stop. Okay, go up. Okay. Why? You press stop. Okay, you go below 200.
Below 200.
Okay, so below 200, this one green, right? Right.
Yes.
Okay, press that. Okay, go above 200. Off already, wait. You see? But this one is still on, right? So the latch must be after the compact.
The latch after the call.
Correct.
Because
Because this one, this condition, okay, all we see as a condition function. Condition function easier. So this condition here is to energize the motor only. That's all. After that, it's not for cut off the motor. So earlier is energized already, but if I put here, it's cut off the motor. So I don't need. So I must be after the comparison, the latching, right? Drag. No. Just drag. Okay. Another thing. Okay, you see, you already used the compare here, right?
Yes.
Go down, which is the same thing is this one, correct?
Yes.
Then I don't need this.
Memory.
Don't need to remove. You understand or not?
So let's say this one I don't want to put using memory here.
Yes. Then you can use that. If I straight away use the this one, can, because like I said, compare is like normally open,
Yes.
so I can use it. But here, of course lah, I cannot use. I must use this one, right? Like this memory cut off because I want to cut off.
Yes, true.
But to on, I can use this, no problem. Okay? You know, I mean, you try, that is okay. For me, the logic we cannot do, not an issue, like I said, okay? But you know how the compare works, okay? How to do scaling. And I believe all of you already familiar with the software. You know how to download, you're only struggling in the logic. Correct.
The what you
Memory.
The memory okay.
Memory okay?
I just confused on the CTUD, yeah, that one.
Counter up, down.
Yeah, that one I confused.
Okay, later we learn later we can.
This one I very confused.
I need to put in the figure or what, then link to. This one normally I use for the sensor. So I need to know.
Counter.
Yeah, the counter. I need to know how much, like she said, how much the total. Like for example, and the first station is counting the total. Second station is check the reject. And I need to tally see whether the up going same or not. Then after that the packing. Is it during the packing got any loss or not?
Okay, all this right, you have an idea, right? What you need to do first, you write down a flowchart first.
Okay.
You write down a flowchart,
Yeah.
then from the flowchart you see what input output I need.
Okay.
Write down the input output, use the flowchart, create the program.
Okay.
When you create, then you know, okay, here I need to use compare. Sorry, the counter. What counter I need to use? CTU enough? Okay, use CTU enough.
Yeah.
If I want to count up and down, then CTUD.
Yeah.
If I want to count
like
up
the
only,
packing, like the pack in the carton box, right?
that's what as I said, you cannot fix.
Okay.
Packing must use CTUD. The conveyor must use CTU. You cannot fix.
Okay.
That's what I said. Whatever you want, you do the flowchart
Okay.
and do the I/O. From the flowchart, you know. When you want to do program, okay, you do. So from the flowchart, you say, want to count. Okay, when every bottle, okay, I want to count one. Every bottle in lah. And everything reject, I want to reject. Then you know, okay, for this method, I want to use CTUD. Need to count up, count down. So it's not related to packaging or filling. No. That's why I say every time you do something, I say cannot fix, we cannot confirm. Sketch first. So every time you wanted to make something a statement right, I say cannot write. Why? Because we cannot fix. Because it's a logic. It depends on the individual people. Like the same concept. Let's say the CTUD. I want to. Let's say where is the example? I count here. The bottle okay. Count. There's another station to see, check the cap. Is the cap there? Okay, good. If the cap is not, reject. So I have two sensors now. Okay. You can use CTUD to get the final bottle.
Yeah.
I can use one CTU, another CTD can get the result.
Yeah.
He can use increment and decrement to get the result. At the end, I get the result or not.
Yeah.
That's it.
Yeah. We can use the divide 12 bottle in one carton.
Yes.
The tally see whether really the outcome.
That one also same thing. Okay. When you do flowchart, okay. Now I get all the bottle ready. Now I want to, in the HMI, I want to show how many carton I already ready. So now, when you see the program, okay, now you have a total bottle ready. So how am I going to get the number of carton? What I can use? See, another maybe not. Actually, that one also not necessarily must use calculation. Let's say all the bottle right, all the bottle come and stand by here. Let's say I have a wrapping machine, wrap, then automatically go into a box. Then the box will move right. There itself I can put one sensor there to count the box.
Yeah.
No need to calculate.
Yeah.
So I know how many boxes is there.
Yeah. And also sometimes because we need to calculate, we check whether, like for example, after packing is 14. But going to the wrapping, right, it's only 12. Where is the 2?
Yes. Then good. So one is to count the filling, one is count the wrapping, get two counter value, minus, there's a balance 2.
Where's the
So
balance
where's the balance 2?
Supposedly have to tally 14 by
14 by 14. So if
Ah.
less than, you give alarm.
Yeah.
So I say, all that is a logic. How you want to do program is based on what are the functions you know.
Okay.
Even from the day, first day, right? But this one I won't teach lah. But I will say that okay. When I start, one motor on. After 10 seconds, second motor on. Third motor on. Fourth motor. Let's say I have 10 motor. First day, if I give the project, what do you do? Start motor 1 on, okay, timer. Then motor 2, timer. Motor 3, timer, right? But now if I give you the same project, what do you do? You create a code block, the FB or FC, one block, inside there you do the logic, call 10 times. Later I teach you another function called shift register. That function means every 10 seconds or every regarding your timer lah, then it can give you, it can shift data one. I mean the bit binary, right? 1 1 1. It can do that 1 1 1 1. That one within like a few line only can control 10 motor. So same process, different way of programming.
I'll go back to when you go to school. I just want to check. This time I have a question to like, if let's say, here I create a block already, here I create a block already. So internal there's a running position. Okay, here I create the run over here lah. So when stop, right, all will stop automatically.
No. Okay, when I want to stop, I stop the run.
No, I need to wait, I need to do but
Okay, don't complicate the program.
Okay.
Don't complicate it. What do you want to do? I give you
I
the
just-
idea.
Here after we
The
start.
thing
right?
is, the first thing is, the run is from where?
Run is from here inside the PC.
Inside the PC, right? You open,
Which one?
this, okay.
Here.
This one bring it down.
Which one?
Where is it?
Here.
Here,
When I
right?
start is the main.
Okay, you see, I give you one picture. If FC2 on, then only this memory can on.
Yeah, okay. Okay,
So
okay.
you if you use this one to block, what happen? Your FC cannot even run
No, because only sometimes today. Okay.
because the memory is inside the FC.
Then how if let's say this one, outside the main right? How we stop all the thing?
Okay.
Here is a like here is FB, a lot of FB.
Okay.
Right?
What you do? You put it here. Start. Let's say when I start, then only the run.
Yeah.
For example, okay. Or you put one stop. Anything stop.
Okay.
Okay. What is the address?
Stop.
Okay. What? No. What do you do? No. Additional.
Okay.
Take out.
Okay.
Just change this one.
I
I 0.3.
I 0.3.
Okay.
This one where I
Rename.
stop.
Rename. What? Start or process on or something.
Yeah.
Don't use the same name as start. Start process. Okay. Change. Okay. The stop take up. Money. That's all.
Oh, let's say there is a e-stop.
This is stop.
E-stop that
This stop also similar concept.
E-stop is normally close already, man.
Yeah.
When press only there.
Yes.
Okay. Then e-stop. Okay.
So when I on, then only these two block can work.
Then how about off? We need to off.
This is the off. When I on is on. When I off
let's say
is
this is
off.
only the button.
Then I need to do a push button.
Push button.
Start stop.
Okay. Or start. If let's say two button now.
Two button. Okay. You put it here.
Put it here.
That's it. Then later you on and off lah. Okay. Then you create memory.
Okay.
What memory not in use? M100.0 lah. M20 or M100.
lah.
Is it 20.0? Okay.
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 This is run.
Okay, run I don't can. Put run.
Run. This memory.
Run.
Run process.
Yes. Okay.
Okay.
Let's it.
That's it. That's it.
Always try to create a simple program. Long, no problem. Then here put another switch. I0.4. Stop process.
Stop process. That's all. I use already.
No. You go back to the show all tab because the memory just not already. Okay. This one they got. Okay.
Okay.
Then in front here you put the normally open M20.0.
Okay. Same like just now we done. And this is like okay.
It's a condition.
Okay.
Monitor. Close and open. Your program won't work. No, not go offline. Okay, what do you do? This one pull down.
Okay.
No, don't close. Actually pull down. Because am I okay. Monitor. See, your program not working because you already blocked. Okay, you on and off. Off back. Now you run. Okay, now you press start.
Start.
What is the compressor value?
Flash.
No. Why like this?
Why? This is not here.
Go to me. Monitor. Okay, because you stopped already the process. You on off back. Okay, don't stop first.
Okay.
Go to your compare. Okay, see compressor running, right? Okay, so compressor running lah, not normal lah. On, off, and run.
Oh, okay.
Okay, can go lah. Okay, don't stop. Okay, let the compressor run lah. Okay, now you stop the process. Go to me. Stop this process. 04 which one? This one? Okay. Now go to the you press stop. Not working, right? Yeah. Because start. Because cannot scan the program. Okay, you cannot run the program already. So program stuck.
Okay. So all will stop.
Stop running, stop scanning.
Okay.
Uh,
But my
But-
thing is still on.
still on because of the program we did. Because we have a latch, everything, right? That's why it's still on.
Any method to off.
Any method to off?
Then this purpose I
No, because Yeah, because the program, because very simple, your PLC is scanning. Suddenly you say stop scan, so it will stuck.
They will automatically like cut off.
No, it's depend on the program unless it's like a input output. So when it stops scanning, so it will stop scan the input. So no output really. But your program we have a latch everything. So that's why it can repeat and still on. So you can use this method lah in that case.
They may create their own block.
Inside here.
Inside here lah.
Inside
Inside here.
there itself you put the emergency stop or what.
Yeah, I create. Like for example,
Yes.
I don't put all any run or something.
Because you know why? Because I never seen any company machine like this. They don't do that.
Why?
Like this one not working right. Normally, okay, why? Like I said, I do for the UTM project right now. I didn't do for all. I only do for one FC because that is the FC. I do the IO mapping. Because what I do in the program all, I didn't use the Q and I use all memory, and now I use another block to do the mapping. With my input on, the memory on. So in the program, I use the memory. Same. I do another one for output mapping. That is memory on, one output. Tomorrow I'll show you lah. I'll show you the program. Very simple only.
That means one I0.0 is the memory of. We set up M0.0. That M0.0 we can use
In the program. So if I cut off that block, the mapping block, so the I cannot on the memory because it stops scanning.
That means the FC here have to put the memory inside instead of the.
I will put memory, then you get another block for mapping. But this one, cannot.
Really cannot.
That's why I say, okay, if any doubt, you just try, then we can understand. Okay, good.
I mean, I create like a new FC for.
Not new, no need. Don't go so complicated.
Okay.
You try to do a simple program. Then use from
in
there.
the main block there. In the main block, we create the memory
Memory for what?
for input and output.
Can main block or you do a separate block.
Then the memory we can link to the if we do the FC, we can use that memory also.
Yes. Tomorrow I'll show you my one code. It's very simple. It's a few I/O only.
Okay.
So for that particular few I/O, so I do that memory mapping. Just 5 input, 5 output.
Not any method to let people complicated to see your program.
Can. Then you do some other language like SCL programming, function block diagram.
Yeah. You do your own program idea.
Ladder. Most of the people know ladder. How to read ladder. Some people basic lah, right? So you do in SCL lah. So nobody will understand. 50-50 lah. Let's say if 10% know PLC, only like basic of PLC everything. Only 2 or 3% will know the SCL programming. So you learn that. But this one rookie, this one cannot convert. If SIMATIC manager, you can do in ladder, then can convert in SCL.
SCL cannot convert.
TI portal cannot convert. You can do, but cannot convert to SCL.
We start from simple first.
Yes, it's the same. Slowly we do practice. Then we try to do a machine, simple program. you want to build a system, right? Always start with like 10 input, 10 output. Make it maximum enough. Maximum 10 input, maximum 10 output. Don't go above that. One thing will be difficult, another thing you struggle, you stress out.
The additional input or output slot, right?
Tomorrow we'll fix.
Okay, good.
Because tomorrow we learn analog output first, then the drive. Tomorrow we learn this, we add this, I have two, so we add two PLC, we add this, and one PLC, we add this one. Both are analog output also, same thing.
One question. Before we go, one question.
Yes,
What is the simplest way we can remember or we can distinguish between an FC and an FD?
simplest way. Because both are same. If you ask me, both are same. Only different is the function block have a DB to keep data lah. That's all. So both
That's for FD and function block.
function block
It has a data block.
is as a data block where it can keep the values lah in the DB. Values means it's not like 100, 200 only. 0 or 1 also is a value. Correct?
Data block.
So function block can keep their data inside the data block. The values lah. That's all. FC is a standalone. So normally FC we can use as a subroutine.
Can FD use as a subroutine?
Can also, but very slow. Because straight on DB you are wasting one DB. Correct.
Function block is a DB.
No, function block is a block.
It's a block.
So
DB,
DB is a data block.
data block.
Yes, it keep data.
So different.
Different. Function block is a logic where you create a logic.
Yeah.
Data
Our
block
own
where
logic.
our own logic, any logic
Yeah.
we create logics lah.
Yeah.
Data block is where we keep values, save values. Yes.
I just want to understand the difference.
Yeah.
For FB
Mm.
and FC
Mm.
in the data block,
Mm.
both of them has input,
Mm.
both of them has
Output,
output,
in, out,
out. Okay, only static
function block.
function block have
But FC don't have.
FC.
Yes. Why? Because you see, in function block, when you add another function block inside the function block, it means timer is a function block, right? Counter, right? So when you add that, these blocks, this timer, F their DB, right? So it will give you an option that you want to create separate DB or you want to create the DB that function blocks want to use.
Oh.
So if you choose the multi
Instance.
instance, what happens? The timer will go to the static.
Because in the static, you can use the timer to activate another.
Yes.
So maybe the timer we can do the create maybe but also depend
You come mine is already all depend. That's why, because I don't want to, if it's very easy for me, I say okay, correct, very easy for me. So your mind will start there. Okay, this one means must, this one. Programming, can do any program.
now okay now we create the timer, right? There's a single instant or multi-instant. Single instant is only for this timer.
No. Very easy, very simple. So let's say this is a function block. Okay, I do some programming. Okay, I don't care what is the program. Okay. Now I want to do a timer. Okay. In this function block, I have a input, output, in out, static, right? Correct.
Yes.
The internal text. Now, when I put this one, okay, now here, I have the program blocks. Okay, OB1. Right. Then now you are creating FB, so left one FB1. Right? On the left hand side, under the program block. Okay. Now, when you add timer, what is asking? Do you want to use as a single instance?
Yes.
Single instance means what happened? It will create its own DB, DB1. Okay. So what happened? This DB will be added under what system?
FB1.
No, under system.
Technology.
System resources.
System resources.
So under here, okay, it will create a DB1. Okay. Inside DB1, what you have? Whatever the timer one, that is called single instance. Means it will create its own DB. So I don't care this function block how many times I call, I don't care. Whenever this timer running, it will process here. The data will be saved here. That's all. Okay? Okay. Now, so okay, this is FB. When we come to OB1, okay. So when I call the function block, of course must have a DB2, right? This DB will go to here, right?
Yes.
Under these blocks. Okay. So let's say start, stop. One more loop. So when then I call another timer. So whenever this one running, I give an input. So input on, then the timer running. Right? Whenever the timer running, what happens? Where the timer will keep the value. Set this DB. Okay? That is called multi-instance. Sorry, single instance. The first one lah.
Yes.
Okay. Let's say I choose multi-instance. What happens? If I choose multi-instance, it won't create a DB. So means there's no system DB. What happens? Just put a name. This data will save under the static. Okay? So now go back to here. Now when the inside OB1, when I press start, the timer will run, right? So where's the timer? Because timer, TON must have a DB, right? So where the DB now? It's a sharing with this one. share with this DB. Means inside this DB, I keep the data of the function block. At the same time, I keep the data of this timer also. So this DB will keep two data. One is for the whole function block, and also your timer also. That is called multi-instance. Means now you are using only one DB. Just now single instance is 2 DB. That's the difference.
Can you give like example for
Multi-instance, single instance. No, if you ask me, if you're using function block, you use multi-instance only. Don't use single instance. Multi-instance.
why?
Because I don't want to waste my DB. Why I want to waste my DB?
Okay.
If I single instance, let's say example, inside this function block, I have 3 timers. What happens? Let's say all choose single. So we create here DB1, DB2 already used it, DB3, DB4. All one DB. If let's say I use multi-instance, means all the timer DB all will go to here. So now I don't need to use this one already.
But the function is still the same.
Function is still the same.
Why we create a multi or create a single?
No, there's
Something issue like happen.
not issue. Because they have a timer, they have a counter, all is a function block.
Yeah.
They have some other special function also. For that, you must use single instance.
Maybe don't crash.
Don't clash. So I don't want to share with this DB. I want a single instance.
I need to honestly.
Because you know why? ED is for what actually? Like I said, to keep data.
Yeah.
That's all, right?
Yeah.
Okay. Some other functions like some they call like parameter DB. That's some DB like additional DB. For that DB, I don't choose multi-instance. I will choose single instance. Why? It will create a separate DB for that. Not timer, some others. Okay? So what happens? If I want to see the value, the data, I straight away go here and see. I don't need to go here and search. If the program is very big, inside here got so many data. So where I want to go and search?
You mean inside the system, the resource there, we can search this data here, this
Yes.
data here, this data
Yes.
here.
So to see the value, all troubleshooting, all that. In FC, no static, right? So cannot use multi-instance.
Only single.
Only single. In FC.
Okay.
Because in FC don't have DB to share. So cannot use.
Yeah. For some of the people, they want to faster to find out the data.
Yes. That's what I said. For timer, if just be timer, I don't need. Some other functions, maybe I use single.
Yeah. Easy to trace up. I know it.
Pick the data.
We don't need to find one by one or go to the DB and check.
That's why. Tomorrow we see this program, company program. The one is what PLC? Moses, the one you see your company program.
It's
1002.
one is 1002, another is S7-1500,
Oh, okay.
but it's using TIA portal software.
Oh, the TR put also. Okay,
Not
good.
SIMATIC manager. Yeah.
Okay. And okay. And I should.
How? I don't know lah, but before I attend this class, right, a lot of people they prefer the S7-300 something. S7-300 instead of like 1005 or 1002, right? They more prefer like the older one. They say more stable.
Yes.
Why? Really more stable.
Yes, stable. Because you see the 300, I think is in the market, I think more than 20. More than that. Because the SIMATIC manager software itself is a 1995. So it's around 30 years already. Still in the market.
Yeah.
Even the S5, I think more than 40 plus years, you know, still company using.
Yeah.
So this 300, this 1002, 1005, so in the market it's around 10 years plus now, right? So easy to, you know, the components inside easy burn, easy spoil,
Yeah, they said always come out a lot of error.
error lah, communication error.
Ah.
That pot easily, you know, the pot easily got problem. So that's why a lot of people they prefer that for heavy usage lah.
Yeah.
For light usage still, but still the 1005 is the Siemens powerful lah.
It's the latest one.
Latest one is the most powerful lah, the 1005. But if someone who, you know, do machinery, work in industry for more than 20 years plus, you ask them, they prefer 300.
Yeah.
Because one is a straightforward, not much functions, not like that. They have also, so I mean, not necessary. So many additional features which is we won't be using also.
Okay. So tomorrow is last day.
Yes.
Yeah. Oh, so fast. So fast.
So tomorrow we'll look at drive programming.
What is it?
So tomorrow is drive programming.
Yes. Tomorrow what we do, morning when we come, we set up the blue color motor to this PLC, the center PLC. Because I have one motor. So this laptop we connect to a router, so we connect that. So at the same time I will connect an analog output card lah. So we just do a simple program on off the motor. Then at the same time we can connect the drive also. So maybe in the morning we connect both the motors lah. We get one setup, put the HMI everything there. Then we try to do a program, simple program. So I will guide you lah. So we do a simple program with the proper addressing where to use FC, where to use FB, all that. Then once you understand how this motor works, how that motor works, all that, right? Because we still need to learn compare that already, right? We still need to learn DB and the move function. So once we done, all understand, then maybe the last 1 hour or 2 hours we can see your program. How so you guys also can see how it works, the program is done. Okay, good.
We have some questions to ask. We can
Of
ask.
course can ask. Because when you ask, then only I know until what level you understand. Okay, this topic, the question you asked already, the way you asked me, I know already. Okay, this one you really understand. So the way my explanation maybe is wrong. So I try to explain it another way.
So one.
Yes.
Tomorrow is we will do communication programming for this one.
Yes.
And
The blue color using what hard wiring program.
Hardwire.
Yes.
This one is
Using communication. So you use communication to control the Siemens drive. We use the DI, AI, AO to the blue color motor. So you can know how to control the drive. So there's a two way to control the drive.
expect me this Christmas. I'm planning to come back this Christmas. So
Christmas.
yes, this end of year.
Okay.
That will be
Want to come for what course?
It's either RM Bradley or Omron.
Okay, sure.
Because at the moment I'm also doing troubleshooting on Omron, but I still need some more things to understand.
Yes.
So I'm planning to come back maybe in this Christmas.
Sure, no problem. Let me know earlier,
Yes.
because now end of the year got a lot of requests. Now a lot of meeting. Now until
No,
November.
every year starting June, the demand will start. So the beginning of the year normally won't be that much. There will be training, but sometimes most of the time will be the company sponsor, or the government sponsor, other government sponsorship, everybody will start. But at that time maybe will start allocating. At the beginning of the year they will try to focus on some other training. But this training will be considered more intensive for them. So they will try to allocate this training to do at the last of the season. So are you currently working in any company?
Yes, I'm working.
Where are you working?
I'm working the refrigeration system. Senai.
Senai also.
You are United Panel. We're doing the cold room.
United Panel.
I'm in the cold room.
The cold room one. Okay.
Because I'm mechanical. Mostly mechanical. Okay, but electrical.
You also mechanical.
That's what we're trying to learn. That's what
Yeah,
we're
because most of the
okay.
cold room. Majority they use Siemens lah.
So United Panel you know before?
Long time already. Last time my boss used to have project with them. They used to do project.
Who?
What is it? So we change the deal and he used to have a very thin white hair on. I forgot his name. Chinese also actually. Yeah. Long time ago already. Around 2013, 2014 time. Those days lah.
So this one once learning, then we need to keep involved.
Yeah.
That's why after this one then.
Sure.
Must practice. That's why at the end of the
But the
training.
component during our
Yeah. Because we build training kit also. We build training kit, but we mainly focus on focus our client to request for training kit mainly for companies or individuals. So we build a custom style training kit with a box. With this type of box. Last time, what's that company name in Senai? UK one. Who bought it?
Super FI.
Super FI. No, Super FI. That one is different. This one who? That last time he used to supply cable for us for the Omron project.
I see.
Tyson also bought, right? That one I think another Bradley.
Yes.
That guy who come for the finance training, he bought our training kit. What?
Farmland.
Oh, what farmland?
Yeah.
Oh, farmland.
I
I think Tyson.
No, Tyson don't have our training kit.
Tyson don't have it. Who's that LA guy? They always like all this. What I was shooting, but but this is our main. We use this box lah. Then you just choose which PLC you want. But obviously, like the big PLC like Omron, all these all cannot lah. Siemens S7-1200. This one also can actually. So we will set up, input and outputs. And if you want HMI also, we can put HMI there. Or a small HMI. So we can code for you lah. Yeah, complex set lah. Depends on which PLC model you want to choose. So this box is very good. So we can set up everything for you. Take at least 2 or 3 weeks. If you set up, we can deliver it to you.
Nice.
So it depends on the cost. It depends on which PLC you choose. Yeah. If you choose the S7-1200, yeah, it will give around 5 to 6. I mean more than that actually. It will give around 8,000 plus. Because we had one client in Sabah. They wanted for S7-1200, right? Yeah.
One question. Let's say PLC long term. Normally, is what component will be problem? Let's say PLC will be facing issue. Is the timing issue, the period issue, normally what kind of issue we have? If not long term, maybe 10 years to do. The more common one.
More common one is the IO lah. Yeah,
I
IO.
remind me one. I used one PLC before. It's Omron. If not mistaken, it's Omron. We have the timer inside. Okay, and we have set the timer already. You want to set also change the display to get. But after don't know why after 1 month, all the setting gone already. Then we have to go and reset again.
Okay. Is happen every 1 month or only one time?
1 or 2 times. Then after that, okay already.
Maybe battery problem.
Or battery problem.
Because Omron, if the battery is failed, battery is low, after it won't erase the program. Some PLC erase the program. But for Omron, if the battery failed, tomorrow you on, still okay.
Yeah.
After 1 week, still okay. But after 2 weeks or 3 weeks, what happened? All the value become, they call irregular. Some different values. Random value.
All the values are uneven.
That means we set like the sequence, right? That means the
All
sensor, they all on already. And we supply.
Yes.
Normally we set 10 seconds. How come become 10,000 seconds already?
Yes. That is for Omron.
Oh, this is like, it's a battery.
Battery
issue.
problem.
Okay. Then in the Siemens, will it happen like this kind of thing?
I think for
Siemens also battery also gone, but Siemens battery is fail. It will erase the values, make it 0. All the value becomes 0. It won't lali.
They make all the setting in one line. Only the
value
the
become
data we save all become 0. Oh my god. There's a big problem, you know.
Yes. That's why the PLCs they use memory card.
sometimes on the HMI you will see like hashtag.
Hashtag.
Yeah.
That one is mostly if you see hashtag in the HMI for Siemens is a communication problem. Communication problem. Some or inside the PLC the data loss.
Why? Also, it's a memory issue.
Memory, battery, or sometimes power trip also can.
That means like
Power trip sometimes it can cost you the PLC to spoil also.
I have like a lot of experience with these issues on Siemens,
Yeah.
where the HMI just go to hashtag, and sometimes PLC just go to stop mode.
Yes, overload.
Yeah.
Suddenly, the power trip on and off, right?
Yeah.
Suddenly power intermittent.
Yeah.
So PLC go to stop mode.
Yeah.
If there's something, if the hardware suddenly one of the hardware suddenly the power trip can go to stop mode.
That means we need to add a memory card for that.
Memory card and proper insulation.
If let's say we put it in the card, right? Then mean if anything issue on the PLC, they will automatically download, or we need to go and download.
No, you automatically can. The PLC,
Uh,
if the PLC program is lost, it can automatically take from the memory card.
oh,
That is the concept lah. I mean the memory card concept.
okay.
But if the PLC normally S7-1200 are mostly on the power, the output input terminal spoil, output terminal one terminal spoil, what?
Yeah, this also got.
What is common? Overload.
These are very common. Anything can be avoided. Because we don't want to make any issue later, we go to site check again one now.
So if you want to avoid this type of power issue, you must use the proper MCB, proper fuses. So every field device, if you think that one can be overload, can use fuse. So if anything happen, only the fuse blow up. So your PLC is still okay.
So for your question about Siemens, I think I have a lot of photos of the era in PLC I went through. And without understanding of Siemens, I tried my best to solve the problem. Go to YouTube, enter the era, all this, I checked, and then morning I went back to work, go to the PLC, try my best, and then I solved it. And all those errors, I keep it in my phone. So maybe tomorrow afternoon, if we can have time for this class, we can show all the errors on the screen and we can see all the PLC errors, Siemens.
I have one funny also, S7-1200. Suddenly memory stuck on, suddenly on. Because there's some issue with the data, then we press the e-stop. So when they press e-stop, of course it will cut off everything. But one of the memory stay on. Because of that, they have like a motor, servo motor supposed to turn left, right, cannot turn right and right, only can turn left. When I go to program and see one is the memory. So when I go through the logic and see, suddenly this memory is supposed not to on. But in the program it's on, right? So I also thinking. Then I think, okay, this is the memory only, right? So I just modify to 0. After modify to 0, when I press that, can go already. Funny problems.
I have to check.
Okay,
See you tomorrow then.
Thank you.
Okay.
I want to discuss with you.
Okay.
How much will it cost? I just want to know the cost.
Yeah, it depends on which spec you want. You want the i7 or i5?
And
i7 or i5?
at least not expensive, but anything that
It's
is
not
run.
cost that comes to you. Okay, what's your budget? I mean, what is your budget?
And I have 300 US dollars.
I should know what's the minimum.
Right, go first.
Okay.
Okay, see you.
Generation i5 16 GB RAM 500 GB SSD can I try to ask my supplier and see by 29 should I tell me that it's too short really I scared that coming to supply me but today's again they will try to take off.
You just check them for the price only, and then it will happen.
Can it will be less than that? It will be around 1,250 I can find for you. 19 ringgit. So it will be around there. But let me try to find out. Let me try to get the supply if we can able to supply by 29. I don't think to have no time or not, so I'm not sure. So let me try and see. We can able to supply. Okay, supply. What I can do is I can just check because I don't think I will have enough time for me to install and check everything, install the AI portal for you, but I can install it for you remotely.
Yes.
Yes.
Maybe we can can give me the software.
I can just share. I can share to you the software link
Yes.
because it's all included in this course anyway. Because you want the track version, yeah? Yeah, because I can install it the laptop. Okay, issue as long because it's alright. We're using the laptop. It seems like stable. That's nice. Yes, for using for programming, but for personal usage, yeah, I don't recommend it. Yeah. I mean, for surfing Google, still can. But to run a TI portal with a big project file should be okay.
That's all. You check and then let me know.
Okay, sure.